everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. And students, today we are going to do top 34 topics from chemistry section. Right, so till now you have done physics marathon and today it's the time for chemistry. Do let me know in the chat box if I am clearly visible and audible to all of you, and how's the energy, how's the Josh? In the comment section, everybody do let me know how was your Deepavali. Do let me know in the chat box, because this festive season, right, we have come up with this marathon because we know that in festive season you are like, okay, we are not in the mood to do anything, but we don't want you to make that mistake, right? Okay, so that's why we will utilize this festive season, right? Physics marathon you have already done. Today it's a time for chemistry, and already I have given you a list of top 34 topics, right? And today we are going to, like, firstly I'll start with either with physical, organic or inorganic chemistry, and I want to know in the chat box, what do you want me to start with? Ma'am, how many hours are planned for this live session? I think so. See, I can't exactly tell you the time, right? But according to me, it should be between 5 to 7 hours, right? Maximum, I think it can go beyond 7 hours, right? Like up to 7 hours. And minimum, I'll try to finish it by 10 p.m. or 11 p.m. See, I'll be also giving you dinner break in between, relaxation break also I'll be giving you. So including all those breaks, it will go like up to 11 a.m. 11 a.m. I'm saying 11 p.m. or 12 a.m. That is predictable, right? Because dinner break also you will need, right? Okay, yes, students, everybody. Yes. Yes, everybody. Yes, physical chemistry, physical, first complete 12, ma'am. Okay. See, what my idea is, I'll firstly teach you 2-3 chapters, or maybe after every 1.5 hours, I'll give you break of 5 or 10 minutes, right? So that your mind can also relax in between and will not break the flow of the session, right? And by 8 p.m., that is your dinner time, right? So at dinner time, my idea is that we should finish at least 2 sub-subjects, like maybe physical or inorganic, maybe inorganic or organic, maybe organic or physical. 2 subjects we should finish, right? If we make that target, then we can definitely do this, right? Okay, so it's a target that we are going to set together, right? Okay, so it's kind of mixed reaction. So I'll just put a poll here, right? Okay, I'll just put a poll and let me see. And also, do guys do like the session, right? There are so many students who have said that yes, I have liked the session, because but only few likes I can see, right? 100 students have polled that yes ma'am, we have liked the session. Only 50 students have liked the session in reality. So let's see if you give vote for organic or inorganic. Let's see, and or physical, the one which will get the maximum percentage, I'll start with that. Okay, I'll start. And block chemistry I'm going to do in the end, because block chemistry is about exceptions and all, so that we can do in the end, right? Okay, so let's see what you say. Organic, 57% organic. Okay, organic, that was unexpected. I thought you will either say physical or inorganic. Organic is actually unexpected for me. Yes, Capto is here. Capto is also here. Yes, Capto Shares is also here. He has already done physics marathon here. Today it's time for chemistry, and tomorrow it will be time for mathematics, right? Yes, students, so I guess so you guys are interested in organic chemistry, so we'll start with organic. See, I told you whatever you say, I'll start with that, but I thought that you would say that ma'am, let's start with inorganic or so I have kept inorganic on the first part, right? But no worries, we'll start with organic then. But before starting guys, let me remind you that offer is going on at this point on the previous year question books, right? That is 1398. It is on the offer price, right, because of the festive season, right? It is actually 1865, but right now it is on the discounted price. So the link is in the description. Go and check that out, right? Here you will get 143 shifts in total along with the answers. I'm saying physics, chemistry and mathematics, all the 3 books will be there in this particular fees, right? Okay, so let us start with organic chemistry. 59% of you are saying organic chemistry, so I'll start with organic chemistry, everybody. I'm going to start with GOC here, right? I'm going to start with GOC here, right? Now GOC in detail we have done, right? Now GOC I'll do that in a way so that you can recall everything that is important for you. We will do that, right? And we'll see what kind of questions are there, right? So GOC is general organic chemistry, and here most important thing is stability of intermediates and knowing the electron displacement effects, right? So stability of intermediates, acidity, basicity, definitely you will see 2 to 3 questions based on GOC, and that too stability of intermediates, acidity and basicity. So that is going to be our first topic, most important topic. A lot of questions are asked from here, right? So if you talk about GOC, there are so many effects. What are these effects? First is inductive effect, right? Other effect is resonance effect, and you should know about all of these things, right? Then there is resonance, then there is hyperconjugation. After hyperconjugation, we have back bonding, that is a part of resonance only, back bonding. Then guys, we have aromaticity, right? Aromatic, non-aromatic, anti-aromatic compounds. These are some of the very, very important things regarding GOC that we are going to talk about, right? So firstly, let's understand. Yes, very good, very good. Now we will tell about the stability of intermediate based on a very simple concept, that is Barhi. Now can you tell me what do you mean by this Barhi, right? Barhi defines the priority of these groups, right? Priority of these electron displacement effects, right? So firstly, we'll always look for back bonding. If there is no back bonding, then we will look for if there is any aromaticity here. That means if any compound is aromatic in nature, right? Then we will see if there is any conjugation or resonance here, right? Then we will see if there is any hyperconjugation here, right? Then we will see if there is any inductive effect here. Now one by one we'll talk about what do you mean by these effects, ma'am, right? So firstly, let's talk about inductive effect, that is actually based on the electron negativity, right? So there are 2 types of inductive effect that is based on the electronegativity, that is minus I and plus I, right? Minus will always define that electron withdrawing groups, and plus I will always define, plus sign will always tell you that electron donating group, okay? Minus sign is always withdrawing and plus sign is always donating, right? So you have minus I and plus I effects here. And talking about the plus I effect, these are the electron donating group. Now which one will have maximum electron donating effect? This is the series here of plus I effect, where CH2 negative has maximum, then NH2 negative, then O negative, CO negative, then you have 3 degree, then 2 degree, then 1 degree, then you have tritium, deuterium, and then you will have hydrogen here. This is the order of plus I effect. Out of this you should know tritium, deuterium and hydrogen are the isotopes of hydrogen, and out of that tritium, then deuterium, then you have hydrogen as the priority. Then here if you talk about the donation of 3 degree, 2 degree and primary, tertiary, secondary and primary. Tertiary has maximum because this has this 3 alkyl groups, so donation will be from 3 sides. Here donation will be from 2 sides. Here donation will be from 1 side, right? And here because they are negative, and the one which has negative charge is always having more donation because it has a negative charge as compared to neutral. Now out of these, why carbon, then nitrogen, then oxygen? Because carbon has least electronegativity. So it would want to donate the negative charge that it has. That's why first is C negative, then you have N negative, then you have O negative, and this is going to be the plus I order here. Now let's talk about the minus I series, minus I order, guys. Minus I order directly also they can ask you. Yes, that is also useful for NEET as well, right? So now guys, if you see this is NF3, right? This is the series of minus I. Electron withdrawal power is maximum in that which has maximum minus I effect, right? So NF3, NH3, then NR3, then NO2, SO3H, CN, CHO, COH. Then you have the halogens, then you have OC6H5, COR, OR, COR, SH, SR, OH. Now here remember that OR has more than OH and SH has more than SR, right? So that is, this is thio, this is simple alcohol and ether, right? Then you have C triple bond, then NH2, NR2, C double bond, that is the order of plus I. As such, you don't need to remember minus I, as such you don't need to remember this, but you should remember in sets. Like you should remember about OR and OH, you should remember SH and SR, you should remember triple bond has more as compared to double bond, you should remember about this NF3, NH3 and NR3, right? Then you should remember about NH2 has more as compared to NR2. So these are the things that you should remember here. This is about the minus I effect, right? Okay. Now guys, next term is you have hyperconjugation. Now hyperconjugation is actually like, firstly let's talk about resonance rather than hyperconjugation. Let's firstly talk about resonance, right? So now guys, if you talk about resonance here, actually resonance is, two cases are present in case of resonance, two things are possible in case of resonance, right? In case of resonance, what is possible? There are multiple things which will show resonance. Resonance is actually delocalization of pi electron. Unshared electrons are only delocalized from one position to other. Sigma electrons are not moved, nuclei will not move here, only the pi electron or unshared electron like lone pairs, negative charge, that can move here, right? So if you talk about this thing here, right, in case of resonance, that we should do in detail, right? In case of resonance, first set is you will have a carbon double bond, then you can have three things. Either you can have a positive charge, or you can have a carbon double bond, you can have a negative charge, or you can have a carbon double bond, you can have a free radical, or you can have a carbon double bond, you can have a lone pair. These are the three things that are possible. These are the four things that are possible, in which case double bond, single bond, p orbital. Now that p orbital can be empty, which give rise to carbocation. It can have one electron, which will give rise to free radical. It can have two electrons, which will either have lone pair or the negative charge. Lone pair means both the electrons are of carbon only, right? Usually this is not carbon. Carbon will not have lone pair, so I'll just make a X negative here, right? Other things will have a lone pair. So This X can be chlorine, oxygen, nitrogen that has a lone pair, right? Then if you have a negative charge, that means one electron is of this carbon, one electron is of this carbon. That do you mean by, see, negative and lone pair both have 2 electrons only, but that is the difference here, right? Now what we will do, what we should know for this thing is, we should know how to do resonance. Always in resonance, double bond to double, this double bond will shift here, right? So here what will happen, this double bond will shift here and this carbocation will shift here, right? That is in case of carbocation, this is the resonance. In case of negative charge, this double bond will, or you can just write it, this negative will shift here, this double bond will shift here. So that means what you will have a double bond here, right? And you will have a negative charge here. In this case, you will have homolytic cleavage. Homolytic cleavage means one electron will go to this side, one electron will go to this side, and here you will have, see, this is a free radical, this is double bond and this is carbon, right? Then guys, if you talk about lone pair, here you will have lone pair to bond pair and bond pair to negative charge, and that is going to be the resonance here. This is negative, this is single bond, this is double bond, this is X positive. Now see if all of them are neutral or not, right? All of them are neutral, right? That means the one, if here it is positive before, it should be positive after also. If this is negative, this also should be negative. If this is having one free radical, this also should have one free radical. If this has, this is neutral overall, this also should be neutral overall. Positive, negative means it is neutral. So this is the first category of resonance. Second category of resonance is alternate double and single bond, right? Second category of resonance is alternate double and single bond, right? If you see this here, this is C double bond, C, then C double bond. In this case, what you do, double bond is shifted here, this is shifted here, and hence you will have a resonance structure that will be C. This is single bond will remain as it is, nuclei will remain as it is. If you want to draw hydrogens here, right, this will be 1, 2, 3, 4, this will be 1, this will be 1, this will be 2, right? So nuclei will remain as it is and the sigma bond will remain as it is. The only difference is in the pi electrons here, right? So pi electrons are shifted here, you will have a double bond here, because from here the electrons are shifted, so it will be a positive charge here. Now the electrons are shifted from this to this place, so here it will develop a negative charge, and that is the alternate double single bond resonance. Okay, yes everybody, that is a alternate double. Double bond, single bond, double bond, single bond, double bond, that is alternate resonance. This is the second category of resonance. So what I have told you here guys, you have double bond, single bond, p orbital. That p orbital can be carbocation, it can be negative, it can be free radical, it can be lone pair, right? There you have 4 categories of resonance, right? And this one you have alternate double single bond resonance. The third category of resonance is the back bonding, right? The third category of resonance is the back bonding, and this is also very famous, right? Now in this case, in the case of back bonding, what you should remember, that always there will be an electron rich and next to it there will be electron deficient, right? For example, here you have C, this is carbocation, and here you have NH2, this is lone pair. Now in this case, this is electron rich and this is electron deficient, so this will shift here and hence you will have the formation of C. Let's say this is C double bond, this is NH2, this is positive because nitrogen is now forming 4 bonds here, so it will be positive charge, right? Okay, or guys you can have, let's say you have carbon negative, this is connected to, let's say it is connected to Cl, right? Now, this can be confusing to so many students, right? This is where they do mistakes, right? Now, you will think, ma'am, this is electron rich, ma'am, this is also electron rich. Now, this is what you should remember from inorganic chemistry, that in the case for the second element of every group, the second element, like you have sulfur, you have chlorine, right? These are having vacant d orbitals, right? So this chlorine has vacant d orbitals. This chlorine has vacant d orbitals. That is the reason what you can write here, that this will actually shift here and this will give rise to this kind of, this is C double bond and this is Cl, this will be positive, this will be positive, no, this will be negative, right? Okay, because extra electrons it is carrying, right? So it will be negative here, right? Or you know what other things you can have? You can also have, this is let's say C negative, it is connected to boron. Now boron is actually a compound, actually an element which is electron deficient. This is electron deficient. Why? Because boron octet is never complete. That is why boron is always electron deficient, right? So these pairs you should remember, that whenever you have an electron rich and electron deficient, that will form back bonding, right? So in that case, back bonding is possible. That is third kind of resonance. Tell me guys if that is clear to all of you or not. Now let's discuss that resonance is also of two types, right? Resonance is also of two types, right? What are these two types? And this is a thing that I will use like when now only I'm going to start with the reactions of organic chemistry. Most important, most repeated reactions we will talk about, most repeated reagents we will talk about, right? Now what you will see that these effects, especially resonance, you will see is applied throughout your reactions, right? So that's why I'm teaching you this before, right? So resonance, if you talk about, it is of two types, and resonance and mesomeric effect is same. In resonance, we say that, let's say in benzene, you have double bond, single bond, double bond, that is resonance. But if you have an external group that is connected here, and because of that external group, there is more resonance here, that is called as mesomeric effect. So if resonance is because of some external group, that is called as mesomeric. And resonance is also replaced by, in benzene, you cannot say there is mesomeric effect. In benzene, there is only, if you talk about, if you talk about this benzene here, there is only resonance. But if you talk about this OH here, in this case, you have mesomeric effect. And that is also called as resonance, right? Okay. So that's why it is also written as plus M or plus R. This also can be written as minus R. Now, what are the compounds that show plus M effect or minus M effect? Let's talk about that. So, a simple trick to remember is that when you talk about a benzene ring, if a group that is connected directly to the benzene ring that has at least one pair of lone pairs, at least one lone pair of electron it has, then it will always and always show plus M effect. Reason being because it is donating. It will donate to this side and these electrons will shift here, right? That is plus M, right? And if you talk about minus M effect here, if you talk about minus M effect here, direct thing is, direct way to remember this is that you will always have a group that is connected to a more electronegative element with a pi bond, right? So here X is more electronegative as compared to G. And this will always and always show minus M because this is more electronegative. It will take out the pi electrons and this will take out the pi electrons from the ring, and hence it is always going to show minus M effect, right? And now because it is donating, that is why these are activating groups. These are activating groups, right? Okay. And here because it is taking away, so that is why it is deactivating group. It is deactivating group, right? Okay. Now, see one more thing here, that in this case, in case of, let's say, any plus M effect you talk about, let's talk about the resonating structures of phenols, right? Let's talk about the resonating structures of phenols. Okay, let's talk about resonating structure of phenols. Now, in this part, I am going to tell you about something, electrophilic substitution reactions, which is related to GOC. Okay, so let's see that. Now tell me, will it show plus M or minus M? You have phenol here, right? This is OH. Benzene is directly connected to an atom which has lone pair of electrons, so it is going to show plus M effect, right? So this will shift here, this will shift here, right? And hence, and it's quite easy, right? Try to draw it yourself as well, right? Here you will have, here double bond, double bond. Now see, these lone pairs have shifted here, you will have a double bond. This has shifted here, you will have a negative charge, right? And this is OH. Now oxygen is connected to 3 bonds. Whenever oxygen has 3 bonds, it will have a positive here. Overall, this is neutral. Overall, positive, negative, this is also neutral, right? Now let's talk about the next resonating structure, that is this negative will shift here. What is double bond, single bond? Negative. Negative will shift here, this will shift here, this we have seen here. This we have already seen here. If you remember, we have already seen negative, single bond, double bond. Negative shift here, double bond will shift here. Same thing I am doing here. Same thing I am doing here, right? Okay. Now, if you see, you will have a double bond here, you will have a negative here because it is shifting here. This is OH and that is going to be positive, right? Next is this will shift here, this will shift here, and hence what you will have, this is going to be, this will shift here, this is double bond, this is double bond, this will be negative and this will be double bond OH, right? Then guys, you have negative will shift here, this will shift here, and hence in the end what you will have. Now can you see, you have 5 resonating structures here, 1, 2, double bond here, this is again OH, right? Okay, 5 resonating structure. Now why I taught you this thing, because one thing to see here, that this position, now always remember, this position is called as ortho, this position is called as meta, this position is called as para. Oh my Prabhu, right? Ortho, meta, para. This is also ortho, this is also meta, right? Okay, so now what you will see, that on ortho and para position, you will have a negative charge. You will have a negative charge on ortho and para position. So if an electrophile is there that is attacking on phenol, or any group which is showing plus M effect, any group which shows plus M effect will always have ortho and para as negative. So if there is an electrophile which is so in love with electrons, electrophile, that means loving the electrons, right, which is in love with electrons, that would want to attack on ortho and para position. So B you have halogen here, right? You have chloro, benzene, bromo, benzene, any benzene, right? Chloro, bromo, halobenzene. You have phenols, you have aniline. In case of aniline, you have here NH2. And nitrogen will also have lone pairs. If you have NH2 here, that is also having lone pair, that will also show plus M effect. So that will also be ortho-para directing towards electrophilic substitution reaction. Remember that, okay? That we are going to do in the reaction part, that always and always plus M is going to show ortho-para directing. Very good, right? Okay. So similarly, when you will see the structures of this one, minus M effect, what you will see, that on ortho, because here when you take out the electron, there will be a positive charge, right? Then you put you take out the electron here, you will have a positive charge here. Then you take out the electron here, you will have a positive charge here. And that is the reason you will have ortho, para, positive. That is why here meta will be more electron density. Meta will have more electron density, and that is the reason you will see that these kind of groups, let's say benzaldehyde. So benzaldehyde is this group where this carbon has a double bond, right? This carbon has a double bond. Carbon is less electronegative as compared to oxygen. It will show minus M effect. So that is why benzaldehyde will show you meta-directing group. Benzoic acid will show you meta-directing group, right? Phenol, aniline, chlorobenzene, they are going to give you ortho-para-directing group towards the electrophilic substitution reaction. Tell me guys if that thing is clear to all of you or not, right? Okay, is that thing clear? That always and always ortho-para-directing groups are shown by plus M effect. And these minus M effect is going to show you meta-directing groups, right? Okay. Now let's see one case of halogens. Halogens is quite different. Halogens. Now in case of halogens, that means this kind of situation you will have. Now they are exception, right? Halogen, because they are electron negative, and electron negative is always going to show you minus I, right? And because they are having lone pairs, they are also going to show you plus M. Now usually mesomeric is more dominating as compared to inductive effect. This we have seen even in Barhi. Even in Barhi we have seen this. Even in Barhi we have seen this. Why? In Barhi, in BARHI, Barhi, this resonance means mesomeric only. Back bonding maximum, then aromaticity, then resonance, then hyperconjugation, then inductive. That means mesomeric is always dominating as compared to inductive. But in case of halogens, things are different. In case of halogens, mesomeric effect is not dominating. Which one is dominating? Inductive effect is dominating. That is why they are deactivating in nature. Otherwise, the one which are showing you plus M effect will always be activating in nature. But these halogen are deactivating. Ma'am, will they be meta? No. Because of plus M here, they will always be ortho-para-directing, right? They will always be ortho-para-directing. And without this thing, organic chemistry is, guys, incomplete, right? It's completely a loss, a big loss, right? Okay, understood, right? Okay, tell me guys, is that clear? Is that getting clear in your head, right? Is that getting clear? Tell me, right? Now let's talk about now hyperconjugation, right? I'll tell you about hyperconjugation, right? See, if you talk about hyperconjugation, guys, I am telling you the things that you will apply. I am talking about the applied version, right? If you want to see the detailed lectures, there are two hours of detailed lecture that I have taken on these topics. You can go and check that out. But I just, before starting organic chemistry, I want to revise this, right? Otherwise, you will feel lost in organic chemistry, right? So, hyperconjugation, if you talk about hyperconjugation, the application part of hyperconjugation is that it is shown by alkenes, it is shown by carbocations, right? It is shown by free radicals, and in case of hyperconjugation, always and always there are two conditions, that you should have alpha carbon should be sp3, right? And there should be at least one alpha hydrogen present here. For example, you have a carbocation, this is the main carbon. Now if you see, this is CH3, this is CH3, this is CH3, right? If you see, this is carbocation, this is CH3, this is CH3, this is H. If you see another carbocation, that is this one, this is CH3, this is H2. Now see which is alpha carbon. Alpha carbon is that is next to the main carbon, that is alpha carbon. This is alpha carbon, this is alpha carbon, this is alpha carbon. Now first thing is alpha carbon should be sp3 hybridized. Yes, it is sp3, sp3, sp3. This is sp3, sp3, this is sp3. There should be at least one hydrogen connected here, right? So one hydrogen is here. So all these are showing hyperconjugation, right? So how many hyperconjugating structures? The number of alpha hydrogen will define the hyperconjugating structure. Here how many alpha hydrogens you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 alpha hydrogens, 3, 6. 6 alpha hydrogens, and here you have 3 alpha hydrogens, right? So more the number of alpha hydrogens, more will be the stability of that intermediate. So that is why 3 degree, then 2 degree, then 1 degree, and that is why the carbocation stability order is 3 degree, 2 degree, and then 1 degree. Is that clear to everybody or not? Right? Okay, 9 means 9 hyperconjugating, very good. So the number of alpha hydrogens will define the hyperconjugating structures. Now ma'am, will it be applicable in case of alkene as well? Definitely. So if you see, I am giving you one more example for more clarity. This is the application part of hyperconjugating. Let's say you have this, this is CH3, right? And let's say this is H. Let's say this is, okay. Let's say this is CH3, this is C double bond, this is H, this is CH3, okay, and you can also put one hydrogen here, okay, 1, 2, 3, and yes, one hydrogen, and this is C double bond, this is CH2, this is CH2. Now if you see, what is the alpha carbon? Now firstly you have to see what is the main thing. This is main, this is main, this is main. Main thing is never included in alpha carbon. So this will be, the next to it will be alpha, next to it will be alpha. This is alpha, okay, and yes. Here you have 6 alpha hydrogens. Here you have 3 alpha hydrogens. Here you have no alpha hydrogens. So the order will be 1, 2, 3. Okay, that's how you tell the stability, right? Okay guys, understood, right? Okay, more the number of hyperconjugating structures, more will be the stability. That is regarding hyperconjugation. Resonance we have done, and then let's talk about aromaticity. Now guys, if you talk about aromaticity, everyone here, let's talk about aromaticity. Let's talk about aromaticity. Aromaticity will tell that there are 3. So I am going to tell you in simple chart form, right? See, 3 kind of compounds are there. First is aromatic, anti-aromatic, non-aromatic, right? And what is PCC? P means planar. P means planar. That means it should be sp2. C means complete conjugation, and another C means cyclic. So planar, cyclic, conjugated, right? If all these conditions are satisfied, then either it can be aromatic or it can be anti-aromatic, okay? If any of the condition is not satisfied, right? Whether it's not planar, there is some sp3 hybridization there, or it is not cyclic, or there is no complete conjugation here, right? Then it will be definitely non-aromatic, right? Then you have to calculate the number of pi electrons here. Now ma'am, what is all this? Let's talk about an example, okay? So let's see, you have this kind of example, that is, let's say you have, okay, let's talk about benzene. Okay. Let's talk about benzene. Benzene is cyclic in nature. Complete conjugation is there, double bond, single bond, double bond, single bond, double bond, single bond. So you can say that yes, complete conjugation is there, right? Then guys, you can also say that if complete conjugation is there, planarity, all the carbons are sp2 hybridized here, right? You can see double bond everywhere, sp2 hybridized. So PCC is followed. Now number of pi electrons are 1, 2, 3, 4, 5, 6. Pi electrons only you have to calculate. 6 means if you put n is equals to 1 here, that will give you 6 pi electrons as the answer. So it is going to be aromatic in nature. Okay. Or you can also say, for example, you have, okay, this compound here, right? This is cyclic. It is cyclic. Conjugation, double bond, single bond, positive, positive, double bond, positive, single bond, double bond, single, positive. So complete cyclic conjugation is there, right? Planarity, this is sp2, this is sp2, this is sp2, right? That means full PCC is followed. Number of pi electrons are 1, 2. This positive does not mean it has a pi electron. So this is 1, 2. If you put n is equals to 0 here, it will give you 2 pi electrons. So that means it is aromatic in nature. Now let's see some examples of anti-aromatic. For example, you have this thing, right? These are some of the very famous anti-aromatic compounds, right? So it is cyclic. It is cyclic. Cycle is there. Double bond, single bond, double bond, single bond, double bond, single bond. Full conjugation is there. Then 1, 2, 3, 4, 4 pi electrons. So if you put n is equals to 1, that will give you rise to 4 pi electrons. So it is anti-aromatic. You have this kind of situation, right? Now here, cyclic, complete conjugation is there. Double bond, single bond, negative, double bond, single bond, negative, it is there. Then 1, 2, 3, 4, 4 pi electrons, that means it is anti-aromatic in nature, right? Okay, got it? Yes, everybody? Acha. Now let's talk about non-aromatic. Non-aromatic, any compound which is not cyclic, that is non-aromatic. If you have a cyclic compound, let's say you have this kind of situation. Let's say you have this kind of situation, double bond, single bond, and here you have a positive. Now there is no complete conjugation, double bond, this is double bond, single bond, positive, positive, single bond, single bond. So that is not a complete conjugation. So it is not there because of there is no complete conjugation, and moreover this one is sp3 hybridized. These are non-aromatic in nature. Okay, these are non-aromatic in nature. And if you talk about the stability of these things, always aromatic, then you have non-aromatic, then you have anti-aromatic. So anti-aromatic is the most unstable compound. No compound wants to be anti-aromatic in nature. If any compound is getting converted to anti-aromatic state, it would rather not do that reaction. So that reaction will not occur only if it is anti-aromatic in nature, right? Then guys, you have annulenes. Annulenes are monocyclic. Monocyclic. Monocyclic means only one cycle is there, and alternate double single bond. Alternate double bonds. Okay. Best example here is benzene. Benzene is monocyclic, alternate double single bond are there. And number of carbons or the number of pi bonds will, pi electrons will tell you the number of that annulene. For example, 4 annulene will be 4 carbons with 4 pi electrons. 6 annulene will be 6 carbons with 6 pi electrons. 14 annulene will be 14 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is karke you will have 14, right? Then 16 will have 16 carbons, 18 will have 18 carbons, but only one cycle will be there, right? Here 8 annulene, 10 annulene, 12 means 12 carbon, 10 carbon, 8 carbon, and that is the number of pi electrons here. Now directly you can remember here, 8 annulene is quite famous. that 8 annuline, what is 8 annuline? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Alternate double single bond, that is this one. This is 8 annuline. This actually exists in a tub-like structure, like this. It exists in a tub-like structure. So that is why it is non-planar in nature, and whenever planarity is not there, that means they are non-aromatic. So 8 annuline is not non-aromatic. I'm not saying not, I'm saying non-aromatic. 10 annuline, 12 annuline, what about 10 and 12 annuline? 10 annuline, if you say guys, and 12 annuline, because of the hydrogen repulsions. Actually, what will be the structure? It will be a more complicated structure, right? 10 annuline will have 2 extra bonds here, right? So you can make it like this. 1, 2, 3. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is actually 10 annuline. Wait a minute. Chalo. Right? Now 10 annuline is this one because of this hydrogen repulsion. Right, that is non-aromatic. It goes out of plane. Similarly, you have 12 annuline, similar kind of situation. They go out of plane, but in case of further annulenes like 14, 16 and 18 annulenes, enough distance is there. They are more bigger. That is why hydrogen repulsion is not there. Right. So in case of these three are non-aromatic, that you should remember. What is the reason? Then they are not, they mostly ask you non-aromatic annulenes, that you should remember. Now 4, 6, 12, 16, 18, they can be either anti-aromatic or aromatic depending upon the number of pi electron in which category they suits, right? For example, wait a minute, for example, let's talk about 4, that will be anti-aromatic, 6 will be aromatic, right? 14 will be, it will be fall into the 16 will fall into the category of anti-aromatic, 14 will fall into the category of aromatic because 4, 4, 16, 4, 3, 12 plus 2, right? If you put 3 here, 4, 3, 12 plus 2 is 14, 4, 4, 16, right? 4, 4, 16, if you put 4 here, it will be 4 into 4, 16 plus 2, that is 18. So these are aromatic, these are anti-aromatic. Okay? Understood everybody? Tell me. Only one. Shivani, yes. It's a single cycle, monocyclic. Only one cycle is there. Right? Only one cycle is there. Right everybody? Yes. Tell me if there is any problem here. Right? Very good aromatic, very good Sabari, very good Manoj, very good GOAT, Tejaswani, Rama Raju, very good Shivani. Yes, tell me. Is that clear? Now let's do what kind of questions they can ask and how to do that, right? So if you see the correct decreasing order of acidic strength, one kind of question that is very famous is acidic strength question. Right? Now, acidic strength, you should remember that whenever you talk about an acid, right? What is the work of an acid? The work of a student is to study. The work of an aspirant, of a competitive exam aspirant is to study, to do practice. What is the work of an acid in that manner? Its work is to donate the H positive proton, right? So, the better you study, more marks you will get, the better it will give H positive, more stable it will be. So a good acid is the one which donates H positive to a good extent. Now which one will donate H positive to a good extent? If even, now beta, if I tell you, now be honest here, if I tell you one thing, after studying so much, after putting so much efforts, you will get nothing. You will get into IIT, you will get nothing. You'll be like, ma'am, then what's the need of studying? I don't want to study, ma'am. Ma'am, if I being an IITian and somebody else not being an IITian, right, just simple degree they have, if we are going to land upon the same job, right, first placement will be same, And then, ma'am, I want to be a normal person, ma'am. Right? Isn't it? So, same thing. If I tell you that, oh my god, when you get into IITs, your first, the exposure, the kind of exposure you will get, right, the placements, the offers that you will get will be so amazing, right, you will find interesting, you will be like, yes, I want to get into it, right. Why? Because after doing that hard work, you know you are getting into something stable. Similarly, here, after losing H positive, it is getting into a stable carbon ion. It is getting into a stable carbon ion, right? It is getting into a stable carbon ion, right? So that means carbon ion has to be stable. Now guys, understand one simple thing, one simple concept I will teach you here, right? Regarding this one, that I will just write here only, right? Whenever you have carbon ion is like stress. Whenever someone gives you, when someone takes away stress from you, withdrawing groups are there. You will feel happy, you will feel stable. If someone gives you stress, you will feel unstable. And if you have a carbocation is like money. Remember it like this only, okay? If someone takes away money from you, you will be like, I am so sad, someone is taking out all the money from me, right? You will not be happy, you know, if someone takes out money from you, you will be like, I only have 20 rupees, right? You are taking that also from me. What are you doing, right? If someone is like, hey buddy, you need money, I'll help you, right? Then you will become extremely stable. You will be like, I am so happy, I got extra money, right? Your parents are giving you extra money, extra pocket money they have given you, right? You are super duper happy, isn't it? So that you should remember that a carbon ion you have or a carbocation you have. If you are talking about a carbon ion, always remember stress. If someone is taking out stress from you, then you feel very unhappy. So now if you see, this is carbon ion, carbon ion, carbon ion. Now here you have NO2 group, here you have fluorine, here you have CN, here you have Cn. Right? These are the 4 different situations that you have. Now if you talk about this case, NO2 group, that is actually minus I. This is also minus I. This is also minus I. This is also minus I. But which one is a greater minus I series? Now if you remember this series here, if you remember the series here, that's why I told you about this series, that is this one series. Here you have NO2 group which has maximum minus I, then you have fluorine, then you have chlorine, then you have NH2, right? NH2 was there, no? Right? Okay, I think so NH2 was there. No, it was Cn. It was Cn, then Cn is here, right? So NO2, Cn, fluorine, chlorine, that is order from minus I. Now we will answer this. Order you should remember here, right? So maximum minus I factor is NO2, then you have Cn, then you have fluorine, then you have chlorine. So chlorine has minimum electron withdrawing effect, but for a carbon ion which is under so much stress, you need a good minus I effect. That means you need NO2, then you will have Cn, then you will have fluorine, then you will have chlorine, and hence D is going to be the correct answer here. Okay, so that's how, based on these effects, the questions are asked based on acidity, basicity, stability of intermediates, which are very, 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 very important questions, right? Okay, next is the correct order of basicity for the following molecules. Now here they are asking you the order of basicity. Now remember that basicity, a simple funda is that it always depends upon electron donating group and inversely proportional to electron withdrawing group. That means more you have donation, more will be the basicity. That means you need availability of electron should be there. If the availability of electron is there, then these are very happy, they are easily a good base, right? So if you see this here, right, Here you have nitrogen where you are giving the electrons, but here it is also taking away electrons like this. Here this is also involved in delocalization here as well, and it's also giving the electrons here, right? And you have an extra pi bond there, right? So that means this delocalization can also occur like this, right? Here you have two alkyl groups here, and this is involved in delocalization. So maximum availability of electrons, if you see, is over here where you have two alkyl groups. So R will be most basic. Then if you compare P and Q here, right, delocalization here also is there, here also methyl group donation is there, here also methyl group donation. But here delocalization, oxygen is not only dependent upon this nitrogen. Oxygen is like, bro, I also have this double bond here. I am not only dependent upon you. So oxygen will not beg this nitrogen to give me electron, please give me electron, nothing will happen. So here this delocalization will be weak because here, wait a minute. Okay. So here this particular delocalization will be a weak delocalization. So availability of electrons here will be more. So you can say then you will have Q, then you will have P. So RQP is the correct answer here. Let's see. Yes, RQP is the correct answer here. That is based on the presence of the availability of electrons here, right? That you gave the answer in the summation of all these effects, right? Okay, right, everybody, tell me. Okay, now guys, let's start with some very important reactions from organic chemistry. Right, from every chapter I'll tell you some important reactions, like you will see these reactions repeatedly in your exams, right? Okay, and I would say most of the reactions you will see organic chemistry are from these reactions only that I'm going to tell you, right? Tell me, guys. Yes, okay. Now let's talk about this. Let's talk about this, everybody. Wait a minute. Okay. So let's talk about this, everybody. Let's start. Spam the chat box with green hearts, everybody. We're going to start with important reactions, important reagents, some of the most important reactions we are going to do. Let's start with that. Spam the chat box with green hearts so that we can do that. Very good, everybody. Very good. Yes. So let's talk about that. Yes, let's talk about that. Yes. So let's see. Okay, so these are important reactions. Let's talk about that. First is soda-lime decarboxylation. Now decarboxylation, two major decarboxylation reactions you have, right? First is soda-lime decarboxylation, in which you have NaOH, you have CO. This is caustic soda, this is quicklime, right? So now here you have any carboxylic acid salt, right? This CO will be eliminated and this will be converted to RH. That means here if you have N+1 carbon, here the number of carbons in the alkane will be N. Okay? That means with one carbon less alkane is formed here, right? If you say, ma'am, what is the mechanism here? Always remember that carbanion will be the intermediate here. That is why if someone asks you the rate of reaction here also GOC is applied. Whenever if someone asks you what is the rate of reaction, let's say they have given you 5 or 6 carboxylic acid. Okay, they are saying which will show maximum soda-lime decarboxylation. The one which will have, let's take an example. For example, you have, let's say, Cl, CH2, COOH, and you have here NO2, then you have CH2, then you have COH. Now this can be based on acidity also. They can ask you which one is a good acid. That is also a good carbon ion, will be a good acid. Similarly here, which one will show more rate of decarboxylation? By soda lime decarboxylation. That means here we know that this has more minus I effect. That is why this is going to be a better acid. That is the reason this will have more rate of reaction here, and that is the reason you can easily say that this is going to be more acidic, this is going to have more rate of reaction of soda lime decarboxylation. That is the formation of alkanes, right? Next question here is, yes, next reaction is Cole's electrolysis. That is quite similar here. In this also you have RCONA, you have carboxylic acid salt, but here you have electricity, you pass through that. Now electrolysis will take place, and what you will have here is, you will have RR. That means if here the number of carbon is n plus 1, here it will be 2n. If here the number of carbon is n plus 1, here it will be 2n, right? Okay, so RR is formed. Now here you have the formation of free radical. Free radical is the intermediate here. One more thing that they ask you is, which is formed at anode, which is formed at cathode. So at anode, what you have, an electron, firstly homolytic cleavage will take place. One electron will leave, you will have a free radical. Then again here homolytic cleavage will take place, and here CO2 will be eliminated with the formation of a free radical intermediate here, right? So here the intermediate is free radical. Free radical intermediate is formed. Free radical, this is very important, that free radical intermediate is formed in case of Cole's electrolysis, right? Then two will combine, you will have the formation of RR. Now carbon dioxide and alkane is formed at anode, and cathode you will have the liberation of H2, and this overall, because of this OH negative, this is going to be a basic medium, right? Overall here water will accept the electron, you will have OH negative and one free radical hydrogen that will combine to give you H2. So overall this is going to be a basic medium, right? Next two important reactions which are also quite similar, right? That is Reed's reaction and Darzan reaction. Now when you talk about Reed's reaction, in case of Reed's reaction you have alkane, right? You react it with SOCl2, that is, yes, that is sulfuryl chloride, okay. But in case of Darzan process, you have alcohol, you react this with SOCl2, right, and that is thionyl chloride, that is thionyl. Now that is the difference. That's why I have marked these reactions together. This is sulfuryl, SO2Cl2. This is SOCl2. This is thionyl chloride. Okay. So now in case of the products are same, right? Here same number carbon chloride is formed. Here same number carbon chloride is formed with the liberation of SO2 and HCl, which are gaseous products, right? Yes. Yes, learning cathode and anode is important, because based on that also they can ask you the questions, okay? Yes, right? Okay guys, next is Lindlar's catalyst. Now here we have the formation of cis or trans alkene. So first reaction is by Lindlar's catalyst. So when you talk about alkynes, you have the you have the reagents, that is PDH2, catalytic hydrogenation, in the presence of a poison, right, which will not let it convert to alkane, rather stop the hydrogenation at alkene, right? It can be PbSO4, it can be sulfur, quinoline, CaCO2, right? All these things are the poisons that can be there. Now that will stop the hydrogenation at alkene, and here you have the presence, here you have the formation of cis alkene, right? But in case of Birch reduction, if you talk about Birch reduction, same alkyne you have, right? You do hydrogenation, but you have the formation of trans alkene, because in Birch reduction you have Na, Li, you have ammonia, liquid ammonia, or sodium or lithium is used here. So in case of Lindlar's catalyst, you have cis alkene. In case of Birch reduction, you have trans alkene here, right? So that is the difference. Next, guys, we have Beer's reagent. That is also one of the tests of unsaturation to predict whether there is unsaturation or not. This is the test of unsaturation, where you have an alkene, you add cold diluted KMnO4 that is of pink color. This pink color will be decolorized if you have unsaturated compound here. That means this pi bond will break and this will give rise to OH on both the sides, right? That is your new compound is formed here, right? Okay? Yes, everybody, tell me. Diols, and what are these called? These are called as vicinal diols. Vicinal diols. Vicinal diols are formed here. Next, guys, we have Kirchhoff's reaction. That is also a very, see, I am telling you all these reactions are important. You will see all these reactions are your PYQs only, as it is they have asked you these, right? So in this case, what you have, I'm going to talk about a new thing here. So firstly, a pi bond will break, you will have the formation of carbocation, this is double bond, right? And one hydrogen will be attached here. So this kind of situation you will have, right? So when carbocation is there, this is a double bond and this is H2, one OH will be attached here, you will have the formation of enol, right? Now, what is tautomerism? Tautomerism is used in so many ways, right? Tautomerism is when you have enol 1, 2, 3, right? Double bond is shifted here. That means you will have double bond shifted here, and this hydrogen will be shifted here. So you will have CH3 single bond. This is C double bond OH. That means you will have the formation of aldehyde here, right? So this can also be, you will also do this in the preparation of aldehydes, right? You can also do this in the preparation of ketones here, right? So these can be used, right? For example, you have another reaction, CH3C triple bond CH, right? Now here on addition, now in this case, water is added in presence of mercuric ions, right? So this is converted, this is CH3, this is C, this is double bond CH, right? Now this one is added here, hydrogen. If you see, carbocation formed will be this one, right? Why this carbocation is formed here? Because this has OH here, right? So this has the formation of enol, right? Now if you see here 1, 2, 3, right? Now here you have the formation of enol. So this double bond is shifted here. This is CH3, this is C double bond O, right? This is CH, and one more hydrogen is shifted here. So this will be CH3, right? Okay. So now what is tautomerism? Tautomerism is simply double bond is shifted here and hydrogen is shifted here. Double bond is shifted to this position and hydrogen is shifted to the first position. That is tautomerism, and that will give rise to the formation of ketone, right? So that can be the preparation of aldehyde or ketone, that can be the reactions of alkynes, but this is a very important reaction that is called as Kirchhoff's reaction, and this also has been repeatedly asked in your PYQs, right? Okay. Yes. Now guys, next a very important thing is ozonolysis. Like this is again right? I don't know how many times this has been repeated, and it's kind of, yes, it's 1-3 system. Very good, Anjali. So here in case of ozonolysis, you add ozone, right? Ozonolysis of alkene is very famous, right? Repeatedly they ask you the ozonolysis of alkene, right? So how do you answer that, right? So when you talk about reductive ozonolysis, oxidative, two kind of ozonolysis are there. Reductive means, I'll just give you one example also here, right? For example, you have alkene I want to form. So this is C double bond, this is, let's say, CH3, this is CH3, this is H, and this is H, right? So when you have O3, you add it, and there is reductive ozonolysis, right? What you do here, you break the pi bond, you break this bond, right? And you attach double bond O on both sides. So double bond O is attached here. Here also double bond O will be attached, right? Here also double bond O will be attached, right? So that is your reductive ozonolysis, right? Okay, that is called as reductive ozonolysis, right? Now if you see, reductive ozonolysis we have done, but what about oxidative ozonolysis? In case of further oxidation, if you do, the hydrogen that is directly connected to carbonyl carbon, this is the only hydrogen that is directly connected to the carbonyl carbon, that will be converted to OH. So this will remain as it is, this will remain CH3, this will be CH3, but here this one will be converted to, this one will be converted to C double bond O, this is OH, and this is CH3, right? That is going to be your answer of oxidative ozonolysis, where the hydrogen that is directly connected to the carbonyl carbon is converted to OH. Got it, everybody? Is that clear? Is that clear? In reductive, break the double bond, attach double bond O, right? When you talk about further oxidation here, right, then the hydrogen that is directly connected to carbonyl carbon, that will be converted to OH, right? Okay. Acha, initial structure has 2 hydrogen, then this will change. I'm so sorry guys, then this will change, right? This will be hydrogen, and here this hydrogen also will be converted to OH. So this also will be converted to OH. Now if you see, this is nothing but this is actually H2CO3, which further decomposes to H2O and CO2, which is not stable, right? So always H2CO3 is always directly converted to H2O and CO2, right everyone? Okay. Then next very important reaction is Grignard's reagent. Next important reaction, guys, we have Grignard's reagent here, right? Okay, yes. One is ketone, one is hydrogen, and CO2, that is the correct answer. Very good, right? Acha, now tell me one thing, Grignard reagent shows 2 kind of reactions, right? Majorly 2 kind of reactions are shown by Grignard reagent, right? And this is also a very famous reactions of Grignard reagent. What is Grignard reagent? That is RMGX, right? That is the reaction, that is RMGX. Now in organometallic compounds, R is negative, MgX is positive, right? Because here metal is electropositive in nature, right? See one thing here. Grignard, whenever it sees any proton source, it is directly converted to RH. Now for example, you have RMGX, now water can give you proton, right? So it will directly be converted to RH, alkane, plus this OH will be connected to Mg, so it will be MgXOH. If you have Grignard reagent, there is a proton source, that is alkyne. Now alkyne is also very good proton source because The hydrogen here is acidic in nature. It can easily lose the hydrogen, right? So it is also very good proton source. Again, it will be converted to RH plus it will be converted to MgX. This is C triple bond CH. If you have, let's say, any acid here, right? Any proton, any other proton source you can have, any acid you have here, right? That will also give rise to alkane. So any proton source you have, it will directly give rise to alkane in this case. Okay, got it? Next, this is the first kind of reaction that it is very soft towards proton source, right? Whenever it sees proton source, it's like, okay, I need hydrogen from you. That's it. I'll get converted to alkane. Very simple. Proton source can be anything. Water, it can be any acid, it can be these acidic hydrogens of alkynes, anything can be there, right? Next is, guys, that it also shows a very good reaction with the very famous, these are, with the carbonyl carbons. With the carbonyl carbon, it shows a very good reaction, right? For example, this is negative, this is positive. Now in this case, always and always this reaction will take place like this only. This will attack here, electrons will shift here, and hence you will have the formation of C. This is O negative, MgX, this is positive, it will attack here. This R will attack here and here. These two bonds that I have made can be two hydrogens, can be one hydrogen, one alkyne. It can be two alkyl groups, anything can be there, right? Okay. And after this, further hydrogenation, you will have the formation of OH here. So I'm directly writing OH. Another kind of reaction that is similar to this one is RMgX when it reacts with carbon dioxide, right? Carbon dioxide also we know that this is electron deficient because two carbons are electron rich here. So this is negative, this is positive, it will directly attack here, one electron will see here. See how you have the formation of an acid here. C double bond O, this is O negative, MgX positive here, and here R will attack, and after hydrolysis this will be converted to OH, and hence you have the formation of a carboxylic acid from the Grignard reagent. These reactions are also very famous, guys. If you see, let's say, ma'am, here ma'am we have hydrogen, 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 hydrogen. You have the formation of 1 degree alcohol. For example, you have this is R and this is H. So this will be R and this will be H. You have the formation of 2 degree alcohol. For example, you have both alkyl, then you will have the formation of 3 degree alcohol. So you can have alcohols, you can have carboxylic acid formation from here, right? This carbonyl group can be aldehyde or it can be ketone, and this is a very famous reaction of Grignard reagent. Okay, right everybody? Very, very famous reaction from where definitely you will see one question, right? So these are the reactions that I am not doing full organic chemistry, right? But the reactions that I have picked, you will thank me after this. You will say, ma'am, thank you so much for picking up these reactions, because these are repeatedly they ask you these reactions, right? Okay, so if you're missing this, like if you are like, okay ma'am, the reactions that I'm showing you today, if you miss even one reaction out of this, then guys, that is your fault, because I have told you that these are the reactions that are going to come, and even after that, if you miss those reactions, you don't learn those reactions, you don't practice those reactions, you don't solve the PYQs of those reactions, then it's your fault, right? Because I'm already telling you all of that, right? Now let's talk about some reagents of haloalkanes, haloarenes. First is chlorinating reagent. So now let's talk about any chlorinating reagent. You have PCl5, you have PCl3. Always OH will be replaced here by Cl. This OR will be here replaced by Cl. These are chlorinating reagents, like you have PCl3, PCl5. These are the chlorinating reagents. Okay, you can have brominating reagents as well, right? That is like you have PBr3, PBr5. These are brominating reagents. Then this is a very important reaction that you have KNO3 and AgNO3, right? Now this comparison is asked in either statement based question, they can ask you this. They've already, this is a PYQ, okay? So if you're saying ma'am PYQs, ma'am more and more PYQs, the reactions that I'm telling you is PYQ only, right? So guys, there is a difference how we approach in physics, mathematics or chemistry, right? In maths and physics, right, first you will understand the concept, then you will solve the question. But in case of chemistry, in case of organic chemistry and organic chemistry and inorganic chemistry, theory is only question, right? This theory that I am teaching you, they will ask you this in the form of question. The concept is same, right? So every single slide is a PYQ here, right? So if you talk about KNO3, that is ionic in nature. Because of the ionic nature, this oxygen is free to bond, and that is the reason whenever you have RX reaction with KNO2, you will have the formation of RONO, right? But in this case, because here this AG is bonded to the oxygen, and then you have double bond O. So this bond is a covalent bond. That is why it is not easy to break this bond. That is why this oxygen is not free for the reaction. That is why here you will have the formation of RNO2. Right? Okay? Right, everybody? Tell me. Tell me, tell me, tell me, tell me. Right? Okay? So I think there is also one more kind of reaction that you have, that is KCN, and here you have AgCN. So KCN also is K positive, Cn negative, this kind of situation. But in case of AgCN, you have this kind of situation. That is why if you have Rx plus KCN, you will have the formation of RCN, that is cyanide. But you have Rx plus you have AgCN, you will have the formation of isocyanide here, because this AgC bond is covalent, that is already in a good bond, right? That is the reason that it will not need something else here, right? It will be like this carbon is not free for the reaction, that's why the reaction will occur from the nitrogen, that is why isocyanide is formed here, right? Yes, Cn is also the same, very good, right? Let's do some other reactions of haloalkanes, haloarenes, that are your important reactions, right? First reaction is your Finkelstein and Schwarz reaction, that is your halogen exchange reactions, right? So you already have a halogen here. Let's say here you have RCl, right? Here also let's say you have RCl. In this case, in case of Finkelstein reaction, how I ask the students to remember this, you just remember it by this thing. This is Rx, okay? This is also Rx. So Roxa has a friend whose name is Finn. Finn is asking Roxa every time, put some nail paint, acetone and all that, right? Roxa is always like, no, I don't want to do that, right? So, nahi acetone, no acetone. Roxa is like, no acetone, no nail paint, I don't want to do any fashion here. I am a simple person, right? So, Rx and NaI, here it will be replaced. This is Na positive, this is I negative. I will be replaced here. You have the formation of you can say iodine will be placed here, right? So, now, in case of Schwarz reaction, now Roxa has a best friend called Swati. Now girls always listen to their best friends. Best friend is saying that put some good silver ring AgF, right? So you should have inorganic fluorides here, AgF, Hg2F2, any inorganic fluoride you will have, right? That will react here, and now Roxa will have fashion. Now Roxa will have fluorine here, right? So now it has the formation of RF. So these are halogen exchange reactions, right? What about Hunsdiecker? This is Borodine-Hunsdiecker reaction, right? So do you remember a very famous tube we have? Borolene, 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 borolene. right? So whenever you have any wound, you will apply boroli, right? Standard thing, right? So now how do you remember this? For example, let's say you have a silver salt of carboxylic acid. Someone is wearing a silver chain, going out. Here you should have Cl2 or it can be Br2. I always ask the students to remember, wait a minute, I'll just replace it with Br2, right? Okay. Yes. So here it will be Br2. Okay. Oh, Br2, 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 CCl4, right? Now bad criminals, Br2 CCl4 will attack here. The bad criminals will take out carbon dioxide from here, right? Now this R and this Ag will combine together. Sorry, this R and this Ag I am saying. This bad criminals will give some bad memories to this alkyl group, and they will also take out the silver chain from there, right? So that's why you have the formation of RBr, carbon dioxide is eliminated and silver chain also is taken by the bad criminals, right? That's how you can remember this. Now it's totally your choice, how do you want to remember, right? Now guys, let's talk about the next thing, that is disonium chloride. Now this is about the aromatic, you can say haloarenes, how they are formed. So you have aniline that we will study in amines, right? That is aniline. When you react it with NaNO2 and HCl, 0 to 5 degrees Celsius, right? 0 to 5 degrees Celsius, you have the formation of this disonium chloride. This is called as disonium chloride. Now these disonium chloride reactions are quite famous, right? When you have the formation of chlorobenzene, right, you add CuCl. Now this is a sand-Mayer reaction. In sand you have salt. In sand you have salt. So you will use a salt, that is CuCl, the salt of copper chloride or bromide, along with acid, and you will have the formation of the desired bromo or chlorobenzene, whatever salt you have used. If you have Gaterman reaction, or Gaterman means gutter, bad smell in gutter, right? You will need a powder here, right? So which powder you will use? Copper powder. You will not use a salt, you will use copper powder. Rest of the things are same. You will have acid, right? And then you have the formation of chloro or bromobenzene, that is Gaterman reaction. Next is you add Ki, you simply warm it, you have the formation of idobenzene. Then guys, this is also very important. Then when you add NaBF4, you have the formation of N2BF4, right? From there you have the formation of fluorobenzene, that is also called as Bals-Schiemann reaction. Now if you further react this with NaNO2 and copper couple, you have the formation of nitrobenzene. This part is not a Bals-Schiemann reaction. Till here you have Bals-Schiemann reaction, okay? But if directly to disonium chloride you add NaBF4 or HBF4, then you add NaNO2 copper couple, you will have nitrobenzene, right? Okay? Tell me guys, long time, yes. Oh. I hope so you are fine now. I hope so you are fine. All the blessings are with you. Take care of yourself guys, because once your health is not fine now, then studies will definitely affect, right? So take care of yourself from these diseases that are now there, like dengue and all that, right? Because I have seen so many students getting affected from these things, and one or 2 months are wasted, right, if you have a health issue, right? Okay, so take care of yourself, right? Okay, yes. Now let's talk about some reactions that are important reactions. First is This so we have done already. This will do. Later part we'll talk about Friedel-Crafts acylation, alkylation. We'll talk about that. Firstly, let's talk about Wood's reaction, right? Wood's reaction is you have two alkyl halides, you have sodium ether, and you have the formation of RR. This also is a free radical mechanism. This also follows a free radical mechanism. Here you, in case of Wood's fatigue, you have alkyl halide and you have aryl halide. You have the formation of alkyl aryl, right? In case of fatigue, you have both as the aryl halides and hence you have the formation of biphenyl or diphenyl as the major product. Okay, right everybody, tell me about it, right? Now let's talk about some important reactions of alcohol, phenols and ethers. Let's see that. Let's see some important reactions of alcohol, phenols and ethers. And let's see how many likes you have given here, right? Because I'll give you break, don't worry, I'll give you break. I just want to finish organic chemistry before giving you break, right? Okay, let's finish organic chemistry, then we'll have a break of 10-20 minutes, right? Okay. Yes, I'll definitely provide you with the notes, don't worry. Right, firstly let's finish organic chemistry, then let's take a good break of 10-20 minutes. You relax and then we'll start with physical chemistry or inorganic chemistry, whatever you say, right? Okay, and let's see how many students have liked the session or not, right? Let's see. Till now tell me, is it going fast or the pace is good, right? Yes everybody, yes everybody, do let me know in the chat box. Yes, wait a minute, spam the chat box with green hearts. Yes. So let's see. First, this reaction is very important, which is based on the hydration. Basically, this is the conversion of alkene to alcohol, right? So three things are there. First is acidic hydration, then there is hydroboration oxidation, then there is oxymercuration demercuration. If you talk about acidic hydration, here you will have the formation of a carbocation from alkene, then you will have rearrangement of carbocation, then attachment of OH on the carbocation. If you have hydroboration oxidation, you will follow anti-Markovnikov, that means negative part to more number of hydrogen. And if you have oxymercuration demercuration, that is these reagents, then negative part will be attached to less number of hydrogens, right? Okay, now let's talk about this thing here, right? I'll tell you about one, wait a minute, I'll tell you about one important, let's talk about one, okay, reaction here so that you can understand what I am telling you here, right? Let's see. For example, let's say you have C double bond C, pH, this is H, okay. Yes, let's talk about this one, guys. Let's talk about this one. Now, how with hydroboration, this is acidic hydration. What is the answer with acidic hydration? What is the answer with oxymercuration, demercuration? What is the answer with hydroboration oxidation, right? Hydroboration oxidation, right? Okay, let's see. Now guys, if you see this here, in case of acidic hydration, what you have? In case of acidic hydration, firstly make the carbocation which is more stable. So more stable carbocation is this one, not either it can be this one or it can be this one. This one will be more stable because of CH2 here. This one will be less stable because of 2 hydrogens according to plus psi effect. Because this will show you plus psi effect, this is going to be a more stable carbocation, so it will be CH2. This is CH carbocation, this is this will be single bond CH3, right? Now this is the carbocation, and now we know that hydride shift can take place. Why? Because if it shifts here, if you have the formation of this carbocation, hydrogen shifts here, then guys, if you see, this is the carbocation. Now because of resonance, if you see, this will show you a resonance here. This will show you resonance, positive single bond, double bond. So resonance will be there. Because of this resonance here, we can say that this is more stable, so rearrangement is there. Now you will add the OH here. This is CH, this is OH, this is CH2, CH3. That is the alcohol that is formed if you do acid catalyzed hydration, right? Then if you do oxymercuration, demercuration, you follow Markovnikov rule without any rearrangement. Directly negative part is attached to less number of hydrogen, that is here. So you will have pH, CH2, CH, this is OH, this is CH3. That is the answer. In case of hydroboration oxidation, directly anti-Markovnikov rule will be applied. So negative part is attached to more number of hydrogens. So that means pH, CH2, CH, this is become CH2, this is CH2 and this is OH, because negative part is attached to more number of hydrogens. So negative part is attached here, and these are 3 different answers that you have for hydration, oxymercuration, demercuration and hydroboration oxidation. Okay, right? Tell me, any problem here? Right? Yes. Any problem here? Right? Now let's talk about preparation of phenols, right? Let's talk about the preparation of phenols, guys. Let's talk about preparation of phenols. What are the important reactions? Now I have picked up all the reactions here because this is an important topic. Preparation of phenol itself is a very important topic, right? So first kind of reaction is from benzene sulfonic acid, and this question has been asked to you, right? That you have, see, from benzene to sulfonic acid you will prepare directly by electrophilic substitution, that we will talk about in the end, right? So directly this is sulfonic acid that is formed. First you add NaOH, then you fuse it with NaOH, then you add dilute HCl, and hence you have the formation of phenol, right? That is an important reaction. Then guys, if you have from aniline, you have benzene diazonium chloride. Now in benzene diazonium chloride, when you add water and you warm it, you have the formation of phenol, right? Then third is from Grignard reagent. Now Grignard reagent, if you have phenyl MgBr with O2 dry ether, it will form OMgBr, right? Now once you have OMgBr, you do hydrolysis, acidic hydrolysis, this will be converted to H, that is directly phenol, right? This is soda lime decarboxylation. You have this, let's say this part is R, this is CONA. When you add soda lime, NaOH and CO, directly this part is removed and this is converted to RH. That means this part will be converted to hydrogen. That means here you have the formation of phenols. Next guys, you have chlorobenzene. This is a very important process. This is a very important process, that is Dow's process. This is very important. And this cumene process is also very important, right? Okay. So when you talk about Dow's process, You have chlorobenzene under very drastic conditions, that means very high temperature, very high pressure, you have the formation of phenol from chlorobenzene. Otherwise it's not easy, but from chlorobenzene, if you have very high temperature and high pressure, then it can be formed. Or you have ortho and para positions substituted with electron withdrawing group like NO2, you have the formation of phenol, right? These are the two cases which are possible. Then guys, we have from cumene. Cumene is isopropyl. This is actually isopropyl. This is CH3 on both the sides. So this group is isopropyl benzene, that is called as cumene. When you add O2 and H positive H2O, this is directly converted to phenol, and this will give you phenol plus Sc2. This is also a very important process, where from cumene this is directly formed. Okay, yes everybody, tell me. Then there is distinguished test of alcohols, that is 1 degree, 2 degree, right? Yes. How much time do you get to solve each PYQs? Okay, you guys are asking each other questions. Chalo, good. So Grove's process, guys, that is Lucas reagent. Lucas reagent is anhydrous ZnCl2 and HCl. Now here, this is the distinguished test of 1 degree, 2 degree, 3 degree alcohol. If you have 1 degree alcohol, then if you have 3 degree alcohol, turbidity, that is the cloudiness, that is formed immediately. Turbidity is formed immediately. Then guys, you have 2 degree alcohol where turbidity is formed after 5 minutes, right? Then here turbidity is formed after 30 minutes, and that too prolonged heating. If you prolonged heating is there, and then only, that means 3 degree reacts the fastest, then 2 degree, then 1 degree alcohol, right? And that is the distinguished test of 1 degree, 2 degree and 3 degree alcohol, right? Okay everybody, tell me, is that clear? Let's see. Williamson synthesis reaction, again very important reaction, very important naming reaction. This is when you have an alkoxide that reacts with alkyl halide. You heat it, you have the formation of ether here, right? But the condition is that this alkyl halide has to be primary. If this alkyl halide is not primary, then this reaction will not take place, right? For example, you have a choice, right? You want to prepare this thing. Now, two things you can do. You want to prepare this thing, two things you can do. Either you can select CH3ONA or you can select CH3X. What you will do? You will select CH3X because alkyl halide has to be primary, so it should be CH3X, and alkoxide can be tertiary. Preferred is both should be primary, but if you want to take one as tertiary, you will take alkoxide as tertiary, right? So primary halide should be there, right? Okay, that is a major important part of this reaction, right? Then guys, we have Coles electrolysis here. In case of Coles electrolysis, you have phenol where you add NaOH, this is converted to phenoxide ion. Then you add carbon dioxide, this is converted to salicylic acid. So in case of Coles reaction, you have the formation of salicylic acid, where phenol you have ortho position COH. In case of Reamer-Tamer reaction, from phenol you have the preparation of salicylic aldehyde, but here you use CHCl3 and aqueous NaOH, and here important part is that intermediate is CHCl2 here, right? And the electrophile is, this question also they ask you, electrophile here is CCl2, that is dichlorocarbene is the electrophile here, right? So that becomes your electrophile and you have the formation of salicylaldehyde here as the answer, right? Okay. Now guys, let's talk about oxidation. Again, a very important reagents are used here. There are so many reagents that you will see, right? Oxidation of alcohols, how they will form aldehyde, ketones, different things. How drastic oxidation works, we'll talk about that, okay? Yes, everybody, tell me. Tell me. Ready for oxidation. So basically guys, you have two kind of reagents. One is mild oxidizing agent, other is strong oxidizing agent. Mild oxidizing agents are like PCC, PDC. These are mild oxidizing agent. Strong oxidizing agents like you have cold KMnO4 or Jones reagent. What is Jones reagent? You have CrO3 with H2SO4, that is your Jones reagent. Right, with acetone and H2SO4, that is your Jones reagent, okay? These are strong oxidizing agents. Now, how do they work, right? So, for this, I'll give you a simple thing here, right? This is alcohol, 1 degree, 2 degree. This is mild oxidizing agent. This is strong oxidizing agent. And that one is copper, right? So, this is 1 degree, 2 degree, or 3 degree alcohol, right? This is the kind of alcohol that you have. This is mild oxidizing agent, this is strong oxidizing agent, and this is copper at 300 degrees Celsius. See, in case of mild oxidizing agent, 1 degree alcohol will give you aldehyde, strong will give you carboxylic acid, right? With the same number of carbon, right? 2 degree will give you ketone in case of mild, and strong also it will give you same thing, that is ketone, right? 3 degree there will be no reaction, okay? In case of copper at 300 degrees Celsius, 1 degree will give you copper at 300 degrees Celsius will behave like mild only for 1 degree, 2 degree. That means it will give you aldehyde. And here it will give you ketone. 2 degree though always will give you ketone. But in case of 3 degree, it is going to give you alkene. That is a very important part. That for 3 degree, it is going to give you alkene. Okay? For 3 degree, it is going to give you alkene, right? Okay guys, tell me. Now, I'll be talking about drastic conditions here. Let's talk about that. Acha. If you have 1 degree alcohol, in case of strong oxidizing agent in drastic condition, what will happen? Let's see. Say 1 degree alcohol with strong oxidizing agent is going to give you carboxylic acid. Again with strong oxidizing agent also it will give you the same thing. But with 2 degree alcohol, strong oxidizing agent is giving you ketone. So strong oxidizing agent in drastic condition, if you let's say you have hot concentrated KMnO4, drastic conditions you have. Now ma'am, will it go further? Yes, in case of strong oxidizing agent in drastic condition, it will further go one step ahead. This is not in your NCERT, so you should do this, right? So here, this is 2 degree alcohol, right? This one is converted to ketone, right? The same OH is converted to ketone, right? Now, acha, one more thing, students sometimes get confused here as well, right? So I can also tell you here, for example, this is CH2OH, right? This, let's say this is COH, this is CH3, this is CH. Let's say this is CH3. Now you should know how does it look like. This is 2 degree and this is 1 degree, right? This is CH3. let's say you have CH3, CH2OH. This is converted to aldehyde, that means it will get converted to CH3CHO. Here further it can get converted to CH3COH, right? Here it is converted to CH3CHO. Here it is getting converted to CH3C double bond O CH3, and it is same here. It is same here, right? It is same here, right? Here no reaction, and here how it will take place? This is carbon, this is CH3, this is CH3, one double bond you will have here, because one OH will be eliminated, one H will be eliminated from here. Elimination reaction will take place, right? That's how this will work. Now, if you say that in the drastic condition, what will take place? This is 2-degree alcohol. It is converted to ketone as a strong oxidizing agent. Now, under drastic condition, we know that this is keto form and it is tautomerized to enol form. This is 1, 2, 3. Double bond is shifted here, hydrogen is shifted here. So, you have enol form here, right? Now, again you have a double bond. This double, because it's a drastic condition, this double bond will break. You will have the attachment of double bond O here. You will have the attachment of double bond O here, right? Okay. So, this will be, if you see, this will be converted to C double bond O, H, H. Drastic condition means more oxidation. This is OH, OH. This means this is H2CO3, which is converted to H2O and CO2. So, this CH2 double bond is always converted to CO2 and H2, right? So, we directly write that this is converted to CO2 and H2, right? So, under drastic condition, even ketone is further converted to carboxylic acid. You should remember this, that whether it's hot concentrated KMNO4 or cold concentrated KMNO4, right? Then guys, 3-degree alcohol does not show any reaction with strong oxidizing agent as well. But if it is drastic condition, this 3-degree alcohol will further firstly be converted to alkene. So you will have a double bond here, you will have alkene. Now this alkene will show further oxidation, this double bond will break, right? You will have the attachment of double bond O here, you will have the attachment of double bond O here. So here you will have double bond O, and here this will be nothing but this is actually what? This is CH2 double bond. So whenever CH2, this you have, this is converted to double bond, this is actually converted to hydrogen double bond, which is further converted to OH and OH here, which is further nothing but H2CO3, which is further converted to CO2, so you can directly write it. This ketone is again, this is keto form, this is converted to enol form, that is OH double bond, that means this is 1, 2, 3, double bond is shifted here, hydrogen here will be shifted here, this is enol form, right? In the enol form, further same thing that we did before, this bond will break here, here you will have double bond O, that will give rise to an acid, that is C double bond O, OH and CH3. And here this is what? This is CH2 double bond, that will be converted to CO2, right? Okay? Always remember CH2 double bond, when you break and attach double bond O, that is converted to CO2. Okay? Drastic condition means, no, drastic, see 3 steps you have. Lower level is mild oxidizing agent, then you have strong oxidizing agent, then you have strong oxidizing agent but under very drastic, that means very high temperature, you are giving it very high temperature, heat you are giving it, that's why we are saying hot KMNO4. Here you had hot KMNO4, and in strong oxidizing agent you have cold KMNO4, this is strong, but hot KMNO4 is drastic, like strong, very strong oxidizing agent, right? Okay? Yes, everybody, tell me about it, right? Yes. Is that clear? Is that clear? Yes, everybody? Any problem? Any problem? Let's talk about this very important question, that is when ethers react with concentrated HI. This is also a very important reaction that students usually ignore. This is not a naming reaction, that's why this is ignored, but this is very important. Okay, so here you have ROR with concentrated HI. What you have here, this is H positive, this is I negative. The question is whether this bond should break or this bond should break. If this bond is breaking, you will have negative and this is positive. You should have I here and H here. If this bond is breaking, you should have negative and positive. So this should have I here and H here. So which alcohol should be formed? We know that always you will have the formation of an alkyl iodide and you will have the formation of an alcohol here. Always this will be the answer. But which part will be alcohol and which part will be iodide, right? So if R and R dash, this is a very important trick that I am giving you here, that if R and R dash are SN2, if R and R dash are primary, both are primary, then this will follow SN2 mechanism. SN2 mechanism, guys, means what? Everybody. SN2 mechanism means it is a one-step reaction. It will follow carbocation formation, right? So carbocation formation means it is, wait a minute. No, my bad. SN2 reaction means you will have transition state. You will have no carbocation. This will be dependent upon steric hindrance. SN1 means it is a two-step. Two-step means it will be formation of carbocation, right? So here you will have in R and R dash are primary, then it is following SN2 mechanism. That means it will, I negative will be attached where you have less steric hindrance. If one of them is 3 degree, then it is a SN1 reaction. That means it is going to follow, I negative will be attached where carbocation is more stable. That means 3 degree, then 2 degree, then 1 degree is going to be the correct answer here, right? Okay. Tell me, is that clear? This is a very important conclusion that I have written here. If both are primary, it is SN2, it will get attached to less steric hindrance. If one of them is 3 degree, for example, you have this thing, this kind of ether. Now here you add HI, then one of this part is 3 degree. So I negative will be attached to 3 degree. So that means you will have this situation. This will be SN1 reaction. Okay, this also they can ask you which reaction will be this one. And alcohol, a primary alcohol will be formed here. Right? Okay? Right? So these things you should know. Right, guys? Tell me. Then let's talk about aldehyde ketones and carboxylic acids. Right? Let's see this one. Let's see some reactions here. Yes. Let's see everybody. Let me see how many likes you have given till now. It should be above 200 plus likes by now. Let's see how many likes you have given by now. It should be 200 plus likes by the time I finish organic chemistry, okay? Yes. Everybody, aldehydes and ketones, a very, very important chapter. Some of the here those most important reactions are there and definitely questions will be asked from there only, right? So first is Rosenmund reduction. In this you use Lindlar's catalyst, you use PDH2 in presence of a poison like BSO4, right? COCl, this chlorine will be converted to hydrogen. That means if you have C double bond O Cl, this is converted to C double bond H, right? That is Rosenmund reduction, okay? Where you use Lindlar's catalyst. Then guys, we have Gatterman-Koch reaction. Gatterman-Koch reaction means you have benzene, you add COHCl, anhydrous ClCl3 and CuCl. Directly you have the formation of benzaldehyde, right? That is Gatterman-Koch reaction. This is CHO. How do you remember this? CHO. So CHO is formed here, right? Next is Friedel-Crafts acylation, from where ketone acetophenone is formed, right? If you have here CH3CuCl, acetophenone will be formed. You have benzene, you have RCO. This will be, this kind of electrophile is generated, that will attack here, you will have COR formation. Then the question can be there, ma'am, then why here you have not used HOCl? Ma'am, here also you can have, wait a minute. Ma'am, why here we have not used HCOCl? Because this HC double bond O positive, this is not a stable carbocation. This is not stable. That's why we have used COHCl. That's why it has a different name, that is Gatterman-Koch reaction. Okay? We cannot form this by Friedel-Crafts acylation, right? Next is Itard's reaction. Again, very important. This Gatterman-Koch is also very important. This Rosenmund is also very important. These are very, very important reactions. Itard reaction is, you have chromyl chloride, that is also, that is red in color, right? You have toluene here. On benzene you have CH3, that is toluene. So toluene, when you attach, when you react this with chromyl chloride, right, it has the formation of CHO. That means benzaldehyde is formed, right? Then guys, we have side chain chlorination. This also they have asked you. So whenever you have H mu, that is free radical reaction. Okay. So toluene, here two hydrogens will be converted to, actually the full-fledged reaction is like this. The full-fledged reaction is like this. Here you have C, wait, ouch, I'm so sorry. Okay. C, this will be H, this will be Cl, and this will be Cl. Right, on further hydrolysis, this is converted to, this is C, this is OH, this is OH, and this is H. Now on one carbon, two OH are never stable, so this will leave, water will be eliminated, and hence you will have the formation of benzaldehyde here. Okay, and hence you will have the formation of benzaldehyde here, right? Okay. I'll take break, don't worry, don't worry, don't worry. I'll take break when it is needed, right? Don't worry. I just want to firstly complete this part, right? Because we are left with very few. I don't want to break the flow in between, because if I give you 20 minutes break now, then again you won't be able to do organic chemistry again. Now you are in that flow, right? So my legs are a little bit, I need rest, I know that, but little bit more let's do. Right? Okay, let's complete organic chemistry. So now if you see this here, oxidation, right guys, first I'll talk about reduction here. Two very important reaction of reduction are Clemmensen reduction and Wolff-Kishner reduction. Clemmensen reduction is when same reactant, same products, but the reagents are different. Okay, reactants are, you have here C double bond O, right? In Clemmensen reduction, this is converted to H2, right? In Wolff-Kishner also, this is converted to H2. That means in both the cases, alkanes are formed from ketones, right? But here, in case of Clemmensen reduction, you have acidic condition. You use zinc amalgam in acidic conditions. In case of Wolff-Kishner, you use hydrazine, that is NH2NH2, in basic conditions. So here you have acidic conditions and here you have basic conditions. That is the difference, right? Then let's talk about some of the good test, distinguished test of ketones and aldehydes. Let's talk about that. So basically guys, you have, first is directly you use K2Cr2O7 in acidic condition. That's a very good oxidizing agent. It will directly convert this ketone or aldehyde to carboxylic acid, right? It's a simple oxidation. Now let's talk about these three tests. First is Tollens, then there is Fehling, then there is Benedict, right? Tollens test is given by both aromatic and aliphatic aldehydes, right? First thing is, all these tests are given only by aldehydes. Tollens test is given by both aromatic and aliphatic aldehydes. Fehling and Benedict test is given by only aliphatic aldehydes, right? Only aliphatic aldehydes, right? Then this is Fehling solution test, that is only given by aliphatic aldehydes, and similarly you have Benedict test. In Tollens test you have silver ammonium salt, right? That forms silver mirror, right? If a Tollens reagent you use and you have the formation of silver mirror, you can say that aldehyde is present here. If you use copper 2 positive ions, how do you use that? You have Fehling A and Fehling B solution. In Fehling A you have copper sulfate, that is CuSO4, that is blue in color, right? Blue color is converted to red PPTs, red precipitates, right? Fehling B solution, that is also called as Rochelle salt, is actually sodium potassium tartrate, okay? So when you use sodium potassium tartrate, you have Fehling solution. If you use sodium potassium citrate, right, then that is Benedict solution. The only difference in both the cases, blue color is converted to red precipitate. In both the cases you have red precipitates. Then ma'am, what is the difference in Fehling and Benedict solution, right? Fehling solution we have to freshly prepare it. Benedict solution you can prepare it and store it. That is why Benedict solution is used, right? Okay. Let's talk about very important reaction, that is aldol condensation, right? Okay. Yes. Thank you, Ramaraju. So let's talk about aldol condensation. Let's talk about aldol condensation. Now, aldol condensation is shown by only those aldehydes or ketones which has alpha hydrogens, right? For example, you have CH3, CHO, right? How it is shown, let's talk about that. So you will have an aldehyde. Here also you will have an aldehyde. Okay, CHO, this is CH3. You will write it in a different way. One aldehyde, you will write the alpha hydrogen here. You will write it like this. Wait a minute. You will write it like this. CH2 and this is hydrogen, alpha hydrogen. One aldehyde, you will open the carbonyl carbon here, like this. You will write it like this. Okay. One aldehyde, you will open the carbonyl carbon, other aldehyde, you will open the alpha hydrogen here. Now see, what you are going to do? You are going to attach the alpha carbon of one aldehyde with the carbonyl carbon, right? This is a trick that I am telling you, okay? So this is CH2, right? This is CHO here, it is directly attached to CHO that I am writing here. It is attached with C, this carbonyl. Now this carbonyl is converted to alcohol, okay? So here this will be converted to alcohol, this is OH, this is H here, and this is directly attached to CH3. This is what you will have. Instead of writing it here, I will write it here, right? Okay. Now here this is aldehyde part, this is alcohol part, that is why this is called as aldol, aldehyde alcohol, right? Now after this there will be condensation, that means elimination of water from alpha and beta position. This is aldehyde, alpha and beta position are this. From alpha and beta position, elimination of water will be there, so you will have CHO, you will have CH double bond CH, CH3. Now you will have alpha beta unsaturated aldehydes. You will have the presence of alpha beta unsaturated aldehydes, right? Okay, understood? How do you form this? Now I'll give you one example of cross aldol here. How cross aldol? Cross aldol means two different aldehydes will be there. For example, you have CH3CHO and here you have, let's say, ketone. Let's say you have CH3CH2CHO. So cross aldol means what you will have. Here you will write one as alpha, one as carbonyl. So I'll make two parts here. In this case, let's say I am writing this as carbonyl part, and here I am writing this as the alpha part, right? So instead of writing it like this, I'll have this hydrogen, this CH3 here. Now I'll connect both of them, carbonyl with this alpha. So whenever I am connecting carbonyl with alpha, this is CH3, this is C, double bond O, this is H, this is, let's say, H I am writing here. This is connected to this alpha, that is CH3, that is connected to this CH3, and this carbonyl, wait a minute, one mistake we have done. The carbonyl is also converted to OH, no? So this is also converted to OH. This will stay as it is, right? This is your aldol. Now alpha beta position, here OH will be eliminated, here hydrogen will be eliminated, you will have the formation of CH3, C double bond C, CHO, right? And this you will have CH3 here, this you will have hydrogen here. That is an answer of, that is the answer of when you take this as carbonyl, this as alpha. Now I'll take opposite, okay? Now I'll take opposite. I'll take this as alpha, so I'll write this as CH2 and this is H, so this is alpha. Now I'll take this as carbonyl. When you write it like this, now there is less chances of doing mistake. These two are connected, this is CH, first I'll write this one, this is CH3, always write carbonyl part first. Carbonyl is converted to OH, right? Then this is linked to this CH2. This hydrogen is eliminated. Actually what happens now, in this hydrogen will be eliminated by a base. That is why it will be a carbon ion that will act as a nucleophile and will attack on this carbonyl group. Actually it happens like that, but right? Okay, so I am giving you a simple trick here. So this is CH2, this is CH2, it is connected to CH2 and then CHO. Now alpha beta position, you will have the elimination of water and hence you will have CH3, you will have CH2, this is CH double bond CH, this is CHO, and that is what you will have, double bond CH and this is CH. Okay, this is the answer that we are going to have. Okay, right? Achha ma'am, is there any other possibility of cross aldol? Yes, this can do self aldol with this aldehyde. This can do self aldol with this aldehyde. So that is also possible. 4 products in total will be possible. In the similar way, you will do that. Next reaction is Cannizzaro reaction. In case of Cannizzaro reaction, guys, you will have no alpha hydrogen. Alpha hydrogens will not be there, right? So here you have no alpha hydrogen. One is converted to same number of alcohol. That means this one. Actually, it's a disproportionation reaction. That means same aldehyde is reduced to alcohol and same aldehyde or ketone is reduced to carboxylic acid with the same number of carbon carboxylic acid. So it will be HCOH will be the correct answer because here you have only one carbon here, right? Okay, only same number of carbon, alcohol or aldehyde will be formed. Alcohol or acid will be formed, right? But ma'am, what about cross Cannizzaro reaction? Ma'am, which one will be used? Which one will be alcohol? Which one will be acid? So the one which is less hindered will always be the acid, right? Okay. So less hindered is this one. So this will form HCOH. or you can say HCONA, right? Both are same, right? And this will form C6H5CH2OH. Same number of carbon, alcohol is formed here, right? So this is an important part, that less hindered salt will be formed, right, in case of cross Cannizzaro reaction, right? Next we have is HVZ, Helmholtz-Zielinski reaction. That is, here you have this alpha hydrogen will be substituted by the halogen in the reagents that we use is X2, red phosphorus and water, right? So alpha halo monohalo product is formed. Monohalo product is formed. On the alpha position, you will have the substitution of halogen. So alpha halo, only one hydrogen will be substituted. That is called as HVZ reaction, right? Then guys, next is you have the formation of acetyl and ketyl. Let's talk about that, right? So in case of acetyl and ketyl, let's talk about that. Firstly, if you talk about from the aldehyde, you have the formation of acetyl, hemiacetyl or acetyl. In case of aldehyde, H positive you attack here, it will lead to the formation of hemiacetyl. Let's see what is hemiacetyl. Carbon you have OH, OR, one hydrogen and one alkyl, that is hemiacetyl. Acetyl is when this particular OR is converted to, when this particular OH is converted to OR, when you have two OR, one alkyl, one hydrogen, that is acetyl. Similarly, if you have a ketone, you have the formation of hemiketal or ketal. Hemiketal is when this is placed by one OH, one OR, two alkyl groups. Ketal is when this is replaced by OR. So you have two OR and two alkyl groups, that is ketal. Okay, that is hemiacetal and hemiketal. This is also a very repeated question, right? Then guys, we have when you react ketone with ethylene glycol, right, what happens here? Water will be eliminated and you will have this carbon linked with this OH, this carbon linked with this OH, and this kind of cyclic ketal is formed. Cyclic ketal is formed. This is also a very famous reaction, right? So all these are your famous reaction. Then the next famous reaction is this one, where you have ketone when you react it with NH2Z, right? So what exactly happens? Oxygen and H2 here. That means water is eliminated. RRC double bond NZ. This is formed. Always C double bond NZ is formed here, right? Now this Z can variate. This Z can be different things, and based on that you have this chart. This is directly your NCERT chart, and based on this you have a lot of questions that they ask you, right? Z can be hydrogen, alkyl group OH, NH2, NH phenyl, NH orthopara substituted phenyl. It can be NHC double bond or NH2. So many things can be there. And based on, just replace, what was the answer? Answer was C double bond O. This is NZ. Replace Z here. Z is hydrogen, Z is R, Z is OH, NH2, NH phenyl, NH orthopara substituted phenyl, NHC double bond O NH2. You will have this answer, and based on that you will have different answers. Now Schiff's base is very important, imine is very important, oxime, hydrazone, then 2,4-di, nitrophenyl, semicarbazone, all are very important here. This table throughout is very important for you, right? Okay, right everybody? Tell me. Achha, one more thing that I forgot to write here, that is your iodoform reaction. Okay, that is not a part of this one, I am just writing it here. Iodoform reaction is, guys, it is only, this is when you have, it is shown by this kind of compound, or it is shown by CH3OH. Either you should have this kind of compound or this kind of compound. This kind of group should be there in that compound, and it will show iodoform reaction. Whenever you have this iodoform, means you will have the formation of CHI3 yellow precipitates. That is also a very, very famous reaction, famous test, right? Okay. Chalo. Now let's talk about amines. That is the last part of this particular organic chemistry, right? Then we'll start with some other part. Now in case of amines, usually the questions are asked on either 3-4 reactions here we have that are important, right? Basicity of amines is very important topic, that is based on GOC, right? So basicity of amines you should definitely know, right? Then guys, let's talk about preparation, right? So reduction of nitro groups, if you have NO2, you reduce it in presence of SnHCl or iron HCl or directly catalytic hydrogenation or any reducing agent, that is converted to RNH2. Hoffman ammonolysis is when you have alkyl halide, you add ammonia, that is converted to NH2. Mendius reduction, when you have cyanide on using any reducing agent, that is converted to RNH2. Basically, this is actually converted to RCH2NH2. This is actually converted to RC and is converted to RCH2NH2, right? If you have reduction of amides, now two kind of reduction of amides are there, right? One is this reduction where you have RCONH2, that is Hoffman bromamide degradation. If you use bromine in presence of a base, then the CO group is eliminated here. Then the CO group is eliminated and here you have the formation of RNH2. But if you directly use a simple reducing agent, then directly you will have RCH2NH2. Now it depends upon what you are using. Now this Hoffman bromamide degradation is a very, very, very important reaction. Okay. Then there is another important reaction, very, very important reaction, that is Gabriel phthalimide synthesis. In this case, this is called as Gabriel phthalimide, where when you add QH, this is converted to K, then you add RX, this is converted to R, then these two bonds will break. Here you have hydrogen, here you have hydrogen, and hence you will have here ONA, you will have ONA and RNH2, that means primary amines are formed here. So you will always write primary amines are formed. In case of Gabriel phthalimide, only primary aliphatic, not only primary aliphatic amines. Aromatic amines you can't make. Primary aliphatic amines, because if you want to make aromatic amines, you have to use here benzene chloride, and this bond is not easy to break. That's why aromatic amines are not formed here, only aliphatic amines are formed. Okay, got it everybody? Chalo. Now let's see the reaction here. Let's see the another reactions of amines. Reactions of amines, the most important part is here carbylamine reaction, then Hinsberg test. These are most important here, right? Okay, let's talk about others as well. Firstly, when you add HCl and NaOH, this can be directly, firstly if you add HCl here, this will be converted to NH3 positive Cl, then you again add base, this will be directly converted to RNH2. So acid base can neutralize it, right? When you add RX here, then what will happen? One hydrogen will be replaced by alkyl. So you will have this. Again you add alkyl halide, one hydrogen will be replaced by alkyl. Again you add alkyl halide, one more alkyl will be connected here forming quaternary salt. Then if you add to the amine part, you add let's say C6H5COCl. So here this kind of situation you will have. So one hydrogen, this is actually called benzylation or acetylation. So in this case, what exactly happens? This hydrogen is replaced by COC6H5. So one hydrogen is replaced by COC6H5 here. This is the same as acetylation. I'll tell you about acetylation also. right? This is acetylation. Here hydrogen is replaced by COR dash, right? Hydrogen is replaced by COR dash. Now, if you have an anhydride, same thing will happen. Hydrogen will be replaced by COR dash. These are called acetylations, right? Where hydrogen is replaced by C double bond O R group, right? Then guys, very important reaction, carbylamine reaction, that is a test of primary amines. So if you have a primary amine, then when you add chloroform and alcoholic KOH, this is same as the electrophile is same here. Electrophile is CCl2, carbylamine is the electrophile here. This will attack and this will give rise to RNC, that is isocyanidase form, which is a false smelling. That is why it has a definite smell, and that is the reason we can identify. If isocyanidase form, it's a primary amine, right? Then guys, if you attack here with HNO2, you will have the formation of, rather than writing this, actually I'll write it in between, you will have the formation of, wait a minute. Actually here, when you add HNO2, this is same as diazotization, you will have the formation of RN2Cl, right? But RN2Cl, aromatic disonium chloride is still stable between 0 to 5 degrees Celsius. Aliphatic is not at all stable. You don't even need to vomit. It will be directly converted to alcohol here. But if you have aromatic, you need to vomit, then this N2Cl will be converted to OH. But in case of aliphatic, you don't even need to vomit, right? Then the last is Hinsberg test. That is actually for the distinguished test of primary, secondary and tertiary. So in case of, what exactly happens, this is Hinsberg reagent, that is C6H5SO2. In case of primary amines, you have the formation of, this is RNH2. This H and Cl will be eliminated, so you will have the formation of RNH, SO2, C6H5. In 2 degree, you will have Rn, SO2, C6H5. This is R2, right? In 3 degree, there is no reaction. Now, the one that you have formed from primary has one hydrogen attached to nitrogen. That is the reason this is alkali soluble. 2 degree amine is not soluble in alkali. 3 degree amine will not show any reaction because 3 degree amine is R3N. There is no hydrogen that can react with this Cl and can react with Hinsberg reagent. Oh, why I have written that? Chalo. NO2, I'll again write it. Wait a minute. Rn2Cl. Positive, negative. Okay. These are some of the important. Ma'am, become RCl. No, ma'am. Where RCl? Where RCl? Where RCl, Lita? Okay. So now some important reagents we are left with. Let's do that. Let's do some of the very, very important reagents of organic chemistry, right? That I have kept in the end, right? Let's see that, okay? Let's see that. Actually, completing organic chemistry like this is most challenging part. Physical and inorganic is still easy, right? Because as such topics you don't have. I have to tell you the most important reactions here. That's why as such topic I can't tell you, but I can tell you that these reactions are quite important, right? So let's talk about alcoholic KOH. Alcoholic KOH is actually a very good dehalohydrogenation. That means if you have, let's say, CH3, you have CH2Cl, then what will happen? This will give rise to CH2 double bond CH2 because hydrogen and halogen will be eliminated from this side, right? And hence you will have the formation of alkene. and ZZ product is formed, that means more alkyl substituted alkene is formed. For example, you have, let's say, okay, let me see what we can make here. You have Cl, you have, let's say, 1, 2, this is CH3, okay, this is CH3, this is CH, this is H, this is CH2. Now halogen will be eliminated from this side. This is beta, this is beta. Now two possibilities are there, either you can have double bond here or you can have double bond here. Which double bond you will choose? You will choose this double bond or this double bond. You will always choose this double bond, not this double bond, because this is more alkyl substituted. Substitution is more here, right? This is more alkyl substituted, that is why this double bond is chosen. That is ZZ product. Then there is dehydrating agents. What are dehydrating agents, guys? Dehydrating, very famous dehydrating agents are concentrated esters, so 4H3PO4, PCl5, P2O5, H3PO4, POCl. Out of this one and this one and this one are quite famous, right? So let's talk about that. Here what you will have, let's say you have CH3, CH2, CH2OH, right? So again what you will have the elimination of, you will have, wait a minute, this is CH3, right? So when you use any of the dehydrating agents here, OH will be eliminated, H will be eliminated, you will have the formation of CH3, CH double bond, CH2. But you know what, when you have alcohols, sometimes they also form ethers as well. So that depends upon the temperature also. If you have 170-degree temperature, it will form alkene. But if you have 140 temperature, what will happen? This is CH3, CH2OH. It is also dehydration will also take place here as well. This is OH. Here dehydration from two different compounds will take place and you will have the formation of ether, that is CH3, CH2O, CH2, CH3. So dehydrating agents can also, at low temperature they can also form ethers, at high temperature they will form alkenes, right? Okay. Right everybody, then there is a next reagent, that is allylic bromination or chlorination. This is if you have N-bromosuccinimide, NBS, or bromine in presence of light or chlorine in presence of light, it will give you allylic substitution. Let's talk about that. What do you mean by that? Allylic or benzylic substitution. For example, if you have this thing, right? Okay. So if I use Br2CCl4 or if I use Br2, this is one of your NCERT question only that has also been asked in your competitive exam, okay. So if you use CCl4, directly nothing will take place here. You will break the pi bond, you will attach Br here, right, and this will be formed. Vicinal dihalides will be formed. If you have light here, allylic means this is double bond, next to double bond this carbon is allylic carbon. This hydrogen will be substituted, you will have CH2 double bond CH, this will be CH2Br, and that will be the answer, okay, right? Tell me, is that clear? Let's ma'am continue. We can discuss this doubt when ma'am gives break. You can discuss yourself all the doubts that you have when I'll give you the break, right? Very few reactions we are left with, guys. Now reducing agents, now based on these two reducing agents also the questions are asked, the difference in LiAlH4 and NaBH4. Very important difference we have here. LiAlH4 can reduce carboxylic acid, ester, acid chloride, all of them to alcohol. But NaBH4 do not react with acetic acid or any other. It cannot react with esters or amides. It can only reduce this RCOCl, ketone, aldehyde or other amides or all, right? That means if you have carboxylic acid, LiLH4 can convert it into alcohol, but NaBH4 cannot. Esters, no. Amides, no. Acid chlorides, yes, both can do. So this is a very, very important difference. Based on this, they have asked you questions based on this. That is one of your PYQ only, right? Okay. Now, do you remember I talked to you about electrophilic substitution reactions, right? That I have already told you, which will be ortho-para directing, which will be meta directing. That is actually based on the plus M and minus M effect that they show. But if you talk about which is the electrophile, so if you have Cl2 anhydrous Cl3 or any Lewis acid, you have X positive as the electrophile. If you have nitrating mixture like concentrated HNO3 and H2SO4, NO2 positive is the electrophile. If you have RCl and hydroCl3, R positive is the electrophile. In this case, you have RCO positive as the electrophile, that is Friedel-Crafts acylation. This is Friedel-Crafts alkylation. If you have oleum or concentrated H2SO4, then you will have SO3H as the electrophile. Actually, SO3 is the electrophile, but when you attach it, because of internal transfer, SO3H takes place, right? Okay. Acha, now based on the electrophilic substitution reaction, you have some exceptions here. So basically what we see that when you have bromine water, phenol, when you have bromine CS2, non-polar solvent, you have ortho and para, different products. One is ortho product, one is para product. Para always being the major product. Unless and until you have any hydrogen bonding in ortho, then ortho will be major product, right? Bromine water, you will have tri-substituted product. But in case of aniline, you do whatever, you use Br2 water, you use Br2 CS2, you will always have tri-substituted product. So if you want to make a para product only here or ortho product only here, then you will have to do acetylation. And acetylation we did before, that when you have any anhydride you can use, or you can also use here CH3COCl, right? Anything like this also you can use. So COCH3 will replace the hydrogen here, right? Then you do bromination, then on the para position only mono substitution will take place. Then you add water and this will be converted to NH2. So this acetylation is a very important concept, where in case of aniline you can have mono substituted product. Now similarly in case of nitration of aniline, what happens? A weird thing is observed. Now we know that aniline is also a ortho-para substitution can take place. Here also technically you should not have meta product. But can you see meta product is formed here, and that too in 47%. That means something weird is there, and that weird thing is that in case of nitrating mixture, that is HNO3 and H2SO4, which is acidic in nature, and this is a base. And this aniline is a base. That is the reason it accepts the proton from this acidic mixture and it becomes, and this is also a very important question, this becomes anilinium ion. And this anilinium ion is the reason that it gives 47% of meta product. And rest of it is para, and very less percent ortho product is formed here. Now ma'am, can I just make para product here? Yes. Similarly, you can do acetylation. You will convert hydrogen to COCH3, then you add nitrating mixture, then only para substituted product will be formed in that case. Okay? Right everybody, now let's do some questions, right, based on these important reactions. Let's talk about that. Right? Let's do some questions guys, everybody here. Let's do some questions, right? Okay? Right? Yes, students, let's do these questions. That is, Aldol condensation is a popular and classic method to prepare alpha beta unsaturated carbonyl compounds. We are saying that aldol condensation with steric hindrance. No, this is not which steric, which are you talking to me? Steric hindrance, no beta, because this is meta directing. This is meta anilinium ion. Because of this positive, this double bond will be shifted here. This is meta directing. That is the reason you have meta directing product here. Okay. Let's talk about some questions here. Aldol condensation is a popular and classic method to prepare alpha beta unsaturated carbonyl compounds. This reaction can be both intramolecular and intramolecular. Predict which one of the following is not product of intramolecular aldol condensation, right? So you have to predict here which one of the following is not a product of aldol, intramolecular aldol condensation. Let's talk about this, right? So if you see this here, first is this compound here, right? This you have to solve and try to solve it yourself as well. I am just going to give you hints here. After the class, try to solve yourself as well. Now here if you see, if you have a double bond here, we know that what will exactly happen if I say this is a carbonyl carbon, right? If I say this is a carbonyl carbon and this is the alpha carbon, they two will be connected here, they two will attach here, this will be connected to OH, right? And after this OH and here hydrogen will be eliminated, you will have a double bond here. And that's how you have the formation of intramolecular aldol condensation. Similarly, here if you see, this is double bond O, this is double bond O. If this is alpha and this is carbonyl, they two will be connected here, right? And this will be converted to OH, and that is why after this you will have a double bond here. That means this is also intramolecular. Then you have this one, right? Then you have this one. So here what you have, this is double bond, this is double bond. This is carbonyl, this is alpha. They two are connected, this is converted to OH. Then this will be further converted to double bond O. So here you have the formation of this, that is intramolecular. Here you have this one last. Now this is not possible, this is intermolecular. How? You have this, if you see this particular compound here, there is no possibility that it can form an intramolecular. If I want to have this as intramolecular, there is no possibility, because it should be double bond, should be then outside. And then these two are connected, this will form a double bond here. It will always form an internal double bond. Here you have external double bond. One simple trick is internal double bond only can be formed in case of intramolecular. If you have external double bond, definitely it is intermolecular. So that means definitely this double bond cannot be within the same molecule. So what exactly happens here? Here you have intramolecular, that means you will have double bond O, you will have hydrogen here, right? What will happen? This carbonyl is getting attached to this particular carbon. This is getting converted to OH here, that is further eliminated, and you will have the formation of this double bond CH2 here, right? Okay. Yes, so answer is D is the correct answer here, right? Next is what amount of, now here stoichiometry and this I will do actually in some basic concepts of chemistry. Do remind me of this one, we'll do that there, right? Why? Because after studying stoichiometry we'll do that, right? Okay. Now which one of the following reactions is not possible? Now they are saying which reaction is not possible, right? You have OCH3 HBr, okay, OH HCl, you have NaOH, high temperature, this is possible, Dow's process. You have Cl2 AlCl3, right, that is also possible, right? Now in these cases, here you have OH is eliminated by Cl, right? And here this HBr, when you add HCl or any acid, This is directly converted to OH, yes, because this is H positive, this is negative, right? This bond we cannot break, so this is converted to OH and this is converted to CH3Br. So this is also possible. This is the same reaction that we did for HBr, same reaction. This is also Dow's process, it is also possible. This is electrophilic substitution, that is also possible. This reaction is not possible, so answer will be second is the correct answer here. Okay? Right, everybody? Tell me. Okay? 2 is the correct answer here. And by that we have completed organic chemistry. Now I'll give you break. I'll give you lunch. Lunch. I'm saying dinner break. I'll give you, right? But before going, right, one very important thing for all of you, that guys, PYQ book is right now at a discounted price, that is 1398. You can check that out. The link is in the description for your practice, right? Okay. You have to do the PYQs yourself as well. The link is in the description. Do that, right? And guys, now I'll give you break. Achha, before doing that, tell me, let us see how many likes you have made, right? And very good. Let's make 300 plus likes before 9 p.m. Okay, it's 8 p.m. before 1 hour. Let's make 300 plus likes. Okay. Yes, will you do that? Will you do that, guys? Will you do that? Yes, everybody. Those who are watching it on recorded version, do hit the like button, comment down which is the best part, right? I would love to see that. Yes, everybody. Acha. Now tell me, after this, what do you want to do? Inorganic or physical chemistry? You want to do inorganic chemistry or physical chemistry after the break? Now even I am very hungry. I'll give you 25 minutes of break. 20-25 minutes of break I'll give you. After that, I'll finish one, like either physical or inorganic chemistry. I think physical chemistry would be better, right? Dinner is not ready, even I don't know if, I think it should be ready at my home, right? So, inorganic, chalo theek hai. We'll do inorganic chemistry then, right? Light part we'll do, and after that we'll do physical chemistry, okay? Yes, everybody? So, I'll be giving you a break now. I'll see you all at, and I'll keep updating you. It's 7:52. I'll see you all at 8:15, okay? I'll see you all at 8:15 p.m. Right? Okay. Yes, everybody. Chalo. Inorganic, I can see the votes for inorganic. So, we'll start with chemical bonding, coordination chemistry, block chemistry after this. Right? Okay. Thank you. Okay, I'll see. Okay then guys, I'll see you. I'm giving you the break and the time is starting now. Okay, so yes, everybody, I am back, everyone. I hope so. You also had your dinner. Yes, students, everybody in the chat box, do let me know if I am clearly visible and audible to all of you or not. Yes, everybody. When I gave you the break, then you guys were present. But now when I'm back, then you guys are leaving. Huh? What's with this one, right? So let me just inform the students that break is over. Yes, everybody. So, Let's start with this one, everyone. Wait a minute. Okay, so yes, students, everybody, let's start, right? So if you see this here, yes, students, so if you see this here, now I'm going to start with inorganic chemistry. Let's start with chemical bonding. So in chemical bonding, majorly two topics from where most important topics too, from where definitely the question will be asked. One is based on hybridization. Hybridization, its shape, they can ask you what is the shape, hybridization, right, of that molecule, what is the geometry. Next is MOT. Based on these two topics, definitely you will see questions in your exam, right? So let's talk about this one. First is, what is hybridization? Hybridization is the mixing of atomic orbitals to form a new orbital with new energy, right? So you have s orbital, p orbital, they intermix to form sp. Similarly, you have when 1s2p are mixed, that is sp2. When 1s3p are mixed, that is sp3. When you have dsp2, when 1d 1s2p are mixed, then you have sp3d, you have dsp3, you have sp3d2, you have d2sp3. All these are some of the important hybridizations that you have, right? Now what is the formula of calculating the hybridization? Okay, so first is, you will calculate the number, that is the steric number of hybrid orbitals, half into total number of valence electron in the center metal atom plus total number of monovalent atoms minus charge on cation or anion. For example, you have CO2, let's say negative, right? Now what is the hybridization? How do you calculate that? You will say half into total number of valence electrons of center metal ion, that is carbon. Carbon has 6 atomic number, it is 2 and 4. So 4 valence electrons are there, so you will write 4 plus total number of monovalent, there is no monovalent atom here, minus charge on cation plus charge on anion, because it's anion, so you will add the charge here, that is 1, it is going to be 2.5 here, right? Okay, now let's talk about, wait a minute, is that correct here? Charge on ion, it should be CO2 2 negative, yes, that's why, no? That's why it should be CO2 2 negative, that's why here you should have 2, that's why, no? It will be 6 by 2, that is 3 will be the answer. And always remember, when the answer is 2, it is sp. when the answer is 3, it is sp2. When the answer is 4, it is sp3. When the answer is 5, it is, wait a minute, this also is possible when the answer is 4. This is when the answer is 5. This is when the answer is 6. So that is the hybridization according to the answer. What will be the hybridization, right? Now, if you talk about, let's say, HF, right? In case of HF, right? Here it is 3, so that is why it is going to be sp2 hybridized, right? In case of HF, the centimetal atom here is fluorine, which has 1 valence electrons, right? So valence electrons are 7 here, right? Plus total number of monovalent is 1. There is no cation, no anion here, so it will be 4. That means it is going to be sp3 hybridized. Okay, this is how you will answer this, right? So now let's talk about Vesper theory. What is Vesper theory? Vesper theory tells you that when certain shape or molecule one atom has to achieve, right, then always you will have lone pair repulsion maximum, then lone pair bond pair repulsion, and minimum will be bond pair repulsions. Bond pair repulsions are going to be minimum in that case, and based on that your shape and hybridization will change here. Okay? So lone pair bond pair lone pair repulsions. Okay? Now I'll tell you some important things here, right? See, we are going to focus on how to solve the questions. Okay, nobody is going to ask you the theory postulates, right? So you should know how to solve the questions here, right? So one thing, if they ask you the geometry, you will always talk about lone pair plus bond pairs. You will include both. When they ask you shape, you will only include bond pairs, right? Now let's talk about how do you answer this, right? Now is the application part. We are starting here. Firstly, I am talking about when you will not have any lone pair, right? Will no lone pair. So how do you calculate whether there will be lone pair or not? Let's see. Firstly, I am directly telling you, wait a minute, I'll be just taking this also in consideration. So guys, if you have 2 electron pairs and there is no lone pair, both are bond pairs, so you will have a linear structure like this. This is A, 180 degree angle, this will be B, 180 degree angle, this will be B. So this will be B, this will be B, that is going to be your answer. That is a linear structure like you have BeCl2 and HgCl2, right? When you talk about 3 bond pairs, and here no lone pair in these cases we have, when you have 3 bond pairs, they are at a 120 degree angle with each other, right? They are at, wait a minute, let me see if I can find, yes, this will give you 120 degree angle. Wait a minute. Okay, so this is 1, 2 and 3 here, that is going to give you 120 degree angle. Okay, so see, this is planar and it is triangle and it has 120 degree angle because 360 divided by 3 is 120, right? So that is trigonal planar, right? Again, no lone pair is there, right? We are talking about when no lone pairs. Now when you have 4 bond pairs, in case of 4 bond pairs, what you will have? You will have a tetrahedral geometry here, right? What is a tetrahedral geometry, guys? This is not planar in nature. This is in 3D. We will see this is tetrahedral geometry, right? You will have 3 angles, 3 bonds here and 1 here. All of them will be at the same angle. That's why after rotation also you are getting the same thing, right? After rotation you are getting the same thing. So that is your 107. Actually it is 109.5 degrees, right? That is the angle here, that is tetrahedral geometry, right? Examples I am not talking about at this point, I will talk about that. First I am just telling you, if you have 5 bond pairs, then what will be the answer? 5 bond pair means you will have a trigonal planar here firstly. You will have a trigonal planar geometry here, right? Okay. Wait a minute. Okay. Trigonal planar, yes. Okay. Wait a minute. Trigonal planar bipyramidal. Okay. So how does it work? Let's see that. Let's see that how does it work, how does it look like, right? Okay. So here guys you have, wait a minute, why I am like showing you by this so that you can remember it for a long time, right? So see, trigonal planar was this kind of geometry, right? That was trigonal planar. Now when you attach one pyramid here, one pyramid you are forming here, one pyramid you are forming above, that is this one, that is trigonal bipyramidal. Okay, so that is geometry is called trigonal bipyramidal. Trigonal bipyramidal is that geometry. Okay. Now let's talk about when you have 6 bond pairs. In 6 bond pairs, guys, what will be the answer? Everybody, what will be the answer? What will be the answer in case of 6? So you will have these 6 attached in the form of a octahedral geometry, right? In the form of a octahedral geometry where 4 you will have at 90 degree with each other. Okay, so I'll just show you that how you will have that at 90 degree with each other, right? All of them will be 90 degree with each other. So basically this is how it will be like. Firstly you will have a square here like this. This is a square here, right? Then you will have 2 pyramids here, right? One pyramid is over here, right? And one pyramid is over here, and that is your square, that is actually square bipyramidal, but it is called as octahedral because of 8 phases it has. So this is the octahedral geometry that we are talking about, right? Okay. Right, acha. Now let's see when you have lone pairs. Now in total you have 3. Whenever you have 3, it is trigonal planar. But now out of that, 1 is converted to lone pair, right? So lone pair, I told you that in case of shape, you don't include the lone pair. So actually when you convert this into lone pair, this particular part is converted to lone pair. So geometry is still trigonal planar, but now the shape will become bent V shape, and that is why the answer is bent shape, right? Okay. Now guys, let's talk about when you have total you have tetrahedral, total you have 4 pairs, out of which 1 is lone pair. So 1 is lone pair. Now what is this? This is trigonal pyramidal, right? This is not planar, this is pyramidal. So that's why here it is trigonal pyramidal is the shape here. Shape is changing, geometry is same, guys, right? Now for example, instead of 1 you have 2 lone pairs here, 1 and 2 lone pairs. Now this is bent V shape, that is why here answer is bent V, right? Next is when you have total 5, right? Total you have 5, and out of this 1 is lone pair, and now lone pair is always on the equatorial side. This is equatorial, the one that is you're able to move, right? That is these are equatorial, this one and this one is axial, right? So always lone pair is on the equatorial side because here you have 120 degree angle between each other. That is the reason here less repulsions will be there. So that's why lone pair is always on the equatorial side. And can you say what kind of shape this is? This is seesaw. It's like a seesaw, right? It's like seesaw. So here shape is seesaw shape. Next is you have two lone pairs. So both equatorial positions are two lone pairs, and here you have T shape. So that's why here it is T shape, right? Okay. Yes, everybody. Now let's talk about octahedral. Octahedral here. Octahedral you have, right? Now, when you have all the bond pairs, it's octahedral. Shape and geometry both are octahedral. If one of them is lone pair, this will become, this is square and this is one pyramid. So, it will become square pyramidal, right? If you have, let's say, two lone pairs, then it is becoming square planar. So, it is becoming square planar, right? Okay, guys, tell me, is that clear? Is that clear? Now I'll talk about that. How do you tell that which one will be two lone pairs, three lone pairs, how many bond pairs? How do you tell that? Okay, so now I'm going to revise that again. But now we will see that if question is given to you, then how you answer. Okay, let's see that. Okay, so one of the examples I'll pick now. This is BeCl2, right? BeCl2. Beryllium is hydrogen, helium, lithium, beryllium. Beryllium means 4. So here you will have two outermost electrons. First you will write the outermost electron, two outermost electrons it will have, right? And two bond pairs you have, two chlorines means two bond pairs. So 0 electrons are left, that means there is no lone pair. That is why you say two bond pairs and two bond pairs you have. That is why two bond pair means you will have linear shape here, right? Then here you have boron. Boron is hydrogen, helium, lithium, beryllium, boron. Now out of this you have 3 electrons pairs. This is 2 and 3. Boron is 5, so it means it is 2 and 3. So 3 is the outermost electron. So 3 minus 3 is 0 lone pairs. That means you don't have any lone pair here. Again 3 is the number of bond pairs. So that will be at 120-degree angle with each other, right? Next is, guys, we have CH4 or NH4. Carbon again has how many, what is the number? Carbon is 6. 6 is the atomic number, 2 and 4. So 4 electron, 4 outermost electrons. And 4 is the bond pairs that you have, so 0 lone pairs. So total number of bond pair plus lone pair is 4. 4 means it is tetrahedral, that means it is sp3, right? It is sp3, and if I am not writing the hybridization, this is sp2, right? This is sp, right? This one will become, wait a minute, right? This one will become sp3 and tetrahedral shape will be there, right? Then here you will have phosphorus. Always do this. How many phosphorus? Now when you have phosphorus, you don't know the atomic number, you will see the family it belongs to. It belongs to group number 15. Group number 15 means it will have 5 outermost electrons, right? Group number 15, guys, it will have 5 outermost electrons, right? So here it will be 3 electron, 5 are only consumed, right? That means no lone pair, right? Again 5 means sp3d, that means trigonal bipyramidal geometry, right? Then you have 6. Now here exactly you have SF6. Sulfur belongs to group number 16, that means 6 outermost electron. Out of this 6 are occupied, so 0 lone pairs you have. 0 lone pairs you have. What do you mean by that, right? 0 lone pair, guys, this means this is octahedral geometry with 6 bond pair plus lone pairs, right? Now let's talk about SO2. Any of this thing you can remember. You can remember SO2 or you can remember O3. Both are same. Okay, I will just take the example of SO2, right? When you have SO2, how do you firstly tell? Sulfur belongs to group number 16, that means 6 outermost electron, right? Oxygen always forms a double bond here. So sulfur will always form double. I am not showing what is the shape here. I am just simply saying oxygen always form multiple bonds, 2 bonds it wants to form. So it forms double bond over here. So bond pairs that are eliminated is 4. That means here 4, 1, 2, 3, 4 bond pairs are occupied. That means 2 electrons. That means 1 lone pair you are left with. So here you will have a lone pair, right? So total number of hybridization actually means sigma plus lone pairs, right? So sigma plus lone pair means sigma is 1 sigma, 2 sigma plus lone pair is 1, that means 3, which is sp2, that means it is trigonal planar. Okay, so answer will be this kind of geometry is the correct answer here. Shape will be bent shape, right? Shape will be bent shape, geometry will be trigonal planar, right? Okay. Similarly, you have NH3, same thing I'll do here. In case of NH3, how do I know that there is one lone pair? Actually, we know that, but let's say we don't know. Okay. So here nitrogen belongs to group number 15 means 5 outermost electrons. 3 will be subtracted here. You will have 2 electrons. That means 1 lone pair. That means total sigma plus lone pair is 3 plus 1. That is 4. That is sp3. That means tetrahedral geometry, out of which 1 is lone pair. That is why trigonal pyramidal shape will be formed here, right? Next we have, this is H2O. Now in this case oxygen is belonging to group number 16, 6 outermost, 2 bond pairs with hydrogens. So it will have 4 electrons means 2 lone pairs, right? So that is the reason here you will have 2 lone pairs here. So that is the reason here you will have 2 lone pairs. So sigma plus lone pair is, sigma is 2 because 2 bonds it is forming, right, with hydrogen, right, plus lone pair is 2, so it is 4, so it is sp3. That is why geometry is tetrahedral, but here you have 2 lone pairs, and that is the reason, as I told you here, in this case when you have 2 lone pairs in tetrahedral, that will be a bent V shape. Okay, this kind of situation is formed here, right? Okay, then you have SF4, right? SF4, same thing, right? Sulfur belongs to group number 16, that means 6 outermost electron, out of this 4 is eliminated. So you have 2 electron means 1 lone pair. Sigma plus lone pair is 4 sigma plus 1 lone pair, it is 5. So it is sp3d, that means it is trigonal bipyramidal with 1 lone pair, that is it is seesaw shape, right? Okay. Then guys we have ClF3. ClF3, guys, these are all your repeated PYQs, okay, all these, that's why I am doing each of them, right? ClF3, chlorine belongs to group number 17, so 7 outermost electron, 3 are eliminated, 3 bonds here, so 4, 5, 6, 7, 4 electrons, that means 2 lone pair here. Sigma plus lone pair is 3 plus 2, that is 5, that is sp3d. So it is trigonal bipyramidal, but 2 lone pairs here, giving rise to T shape, and geometry is trigonal bipyramidal, right? Then you have BRF5. Then again bromine belongs to group number 17, 7 outermost, 5 are eliminated, 2 electron means 1 lone pair. So here sigma plus lone pair is 5 plus 1, that is 6, that is sp3d2, that means octahedral, and that is the reason here you will have a lone pair which give rise to square pyramidal that I have shown you, right? Now you have XCF4, so Xc, xenon belongs to group number 18, so 8, 4 are eliminated, so here you will have 4 are eliminated, here you have 4 electrons, so 2 lone pairs you will have, 2 lone pairs you will have. So here sigma plus lone pair is going to be, sigma is what? Sigma is 4 and lone pair is 2, so it will be 6, that means sp3d2. So it is octahedral, but here this one is octahedral, but here Because of two lone pairs here, it is square planar geometry. Okay, tell me, is that clear? Is that clear, everybody? This we have already discussed. This one also we have discussed, that NH3. But if you see now, in case of CH4, if you have CH4 here, here the angle is 109 degrees. But now the angle is reduced here. Why? Because lone pair bond pair repulsions are more as compared to bond pair. Hence the angle will decrease. Further, from water the angle will further decrease, because here lone pair repulsion will also be there, which will further decrease the angle to 104 degrees. Right? Now, this also I have told you that why always on the equatorial position you will have the lone pair, not on the axial position, because of lone pair repulsions are minimum in the equatorial position. If you have a lone pair here, right, let's say you have a lone pair here, right, so what will happen? Lone pair bond pair, this repulsion will be there, right? But if you have a lone pair here on the equatorial position, here the angle is 120, so repulsion will be with this one and with this one. With these two, the repulsions will be less. So when you are at equatorial position, the repulsions are less. That is the reason equatorial position is preferred here. Right? In the same case, this one will be preferred, this one no, this one no. Right? So equatorial positions are preferred here. Let's do this question based on this one that is asked in JEE 2025. And every year you will see question based on this, right? I don't remember any year when this question was not asked, right? Okay, right? Yes, everybody, let's see. Let's see. We have just done that. Acha, tell me, SF4, I told you that this belongs to group number 16, that is 6 minus 4, that is 2 electron, means 1 lone pair. 4 plus 1 lone pair, that is 5, that means sp3d, right? 1 lone pair, and this will give rise to seesaw shape. So answer will be A is 3. What about BRF3? This beta, I don't need to do that again and again. I have already done that here, right? We have already done that here. BRF3 was trigonal planar. We have already done that, right? If you want me to do that again, I can do that, but it will be little bit waste of time. This belongs to group number 17, minus 3 electron means 4 electron means 2 lone pair. 2 lone pair plus this is 5, that is sp3d2, sp3d, trigonal bipyramidal. But in this case, trigonal bipyramidal will have 2 lone pairs, so 1 and 2, it will give rise to T shape, right? Okay. Then guys, we have NH4 positive. It will give rise to a tetrahedral shape, as clear, right? Then what about BrO3? Let's talk about BrO3. That might be new for you. Bromine is belonging to group number 7. And always it is going to form double bond with the oxygen, right? So it will 1, 2, 3, 4, 5, 6 bonds it will form. 1 negative means 1 electron will be added here, so I will add 1 here. So you will have 8 minus 6 is 2, right? So that means 1 lone pair. So sigma plus lone pair. Sigma is how many? 3 sigma you have. Lone pair is 1, it is 4. So it will be sp3. So it will be a tetrahedral with 1 lone pair here and 1 negative charge here, right? And that is the reason that here this will become pyramidal in shape. That is this one. So answer will be pyramidal is the correct answer here. So answer will be A is 3, D is 1, A is 3, D is 1, right? A is 3, D is 1. So these two are eliminated. B you need to tell, B will be 4, right? So B is 4 here. So answer will be B is the correct answer here. Right? Okay. Tell me everybody, is that clear? Is that clear? Okay. Yes, students. Everybody, I can't see you guys interested here, right? Be active here. No, don't chit chat, guys. Please don't chit chat with each other, right? Okay, let's focus here. So MOT is another topic that is quite important for you. So let's talk about this. In MOT, valence electrons are considered to be associated with all nuclei in the molecule, and the atomic orbitals combine to give molecular orbitals here. So two atomic orbitals can combine to give anti-bonding molecular orbital or bonding molecular orbital. Bonding is always in lower energy, anti-bonding is of higher energy and less stability. It is represented by this star, right? Now, bonding molecular orbital have low energy, high stability involved in bond formation. Anti-bonding is high energy, low stability and not involved in the bond formation. Now, if you see this here, in case of anti-bonding and bonding, for example, 1s and 1s are combining together and bonding will be below and anti-bonding will be above here, right? So, bonding is written as when you add it, anti-bonding is written when you subtract two wave function, we write anti-bonding molecular orbital, right? Now, guys, we have directly designated as sigma, pi and delta. Right, so when you talk about sigma, that is a symmetrical about the axis, and pi is non-symmetrical about the axis. You will have sigma 1s, sigma 2s, right, sigma star 1s, sigma star 2s. You will have pi 2py, pi 2px, pi star 2py, pi star 2px. And Z will be sigma, sigma 2pz, sigma star 2pz. Now this is very important point that Z is taken as sigma. It is by convention that we take Z as sigma, right? Okay. So bonding is sigma, sigma 2pz, sigma 2p, this will be pi 2px, this will be pi 2py, right? Anti-bonding is sigma star 2p, 2s, sigma star 2pz, pi star 2px, pi star 2py, okay? Now, this is very important that you should remember that if you talk about, there is an electronic configuration that we fill. The way we fill, like we have discussed the electronic configuration of simple atoms. This is the electronic configuration of molecular orbitals, right? How do we fill that, right? So first is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Till here both are same. But here things will change. When you have less than 14 electrons or equal to 14 electrons, right? Then you will have, wait a minute. This is more than 14, na? More than 14 electrons, right? This is for less than 14 or equal to 14 electrons, right? So when you have less than 14 or you have equal to 14 electrons, this will take place, right? This will be 1, 2, 2, 1 and this will be 2, 1, 2, 1. Always remember that. For less than or equal to 14 electron, you have 2, 1, 2, 1. You can also remember it like this, 1, 2, 1. I usually do it like this, 2, 1, 2, 1. This is, in the pairs of 2, you will always have x and y. So this will be pi 2px, pi 2py. This will be sigma. This will be sigma 2pz. And these are going to be anti-bonding always. These are going to be anti-bonding. So what I would advise you, just remember 2, 1, 2, 1, 1, 2, 2, 1. Right? In case of less than 14, you will have 2, 1, 2, 1. In case of more than 14, you will have 1, 2, 2, 1. Okay? Just remember this thing and that's how you're going to fill the electrons. And what is the bond order? bond order is half the number of electrons in bonding minus anti-bonding electrons. That will give you the bond order here, right? This trick is also there to calculate the bond order. The trick is that this will mention the number of electrons that you have. For example, in O2, you have one oxygen is 8, two oxygen is 16 electrons. So 16 means the bond order will be 2. And that is why it has a double bond, O double bond O. Let's talk about N2. N2 is, nitrogen is 7, 7 to 2 is 14. So 14 means this, that means 3. So it will have 3 bonds here, right? So it is going to have 3 bonds here. Okay? Tell me guys, is that clear? Is that clear everybody? Tell me. Is that clear? So, energy level diagrams for molecular orbitals, right? If the electrons are if all the electrons in the molecular are paired, that means that is diamagnetic. If there is unpaired electron, that is paramagnetic. More the number of unpaired electron in the molecular, greater is the paramagnetic character of that particular molecule. And you know why MOT was formed? To show that oxygen is actually paramagnetic in nature. That is the reason that this theory was made. Now from this question we will understand how do we apply this theory. You have understood the theory, but how to apply this theory, okay? So they have given you what is the number of unpaired electrons in these molecules. They have given you this and this one, right? So let's talk about that. First is, I'll divide it into 4 parts, okay? Because I'll do in a very, I will do it in a very shortcut method, okay? I'll do it in a shortcut method. Shortcut method means I'll tell you that how exactly to apply it and get the answer, okay? So this is N2, this is N2 negative. N2 means 14 electron, N2 negative means 14 plus 1, that is 15 electrons. Now always remember guys one thing, that if you want to choose 1 to 2 1 or 2 1 to 1, that will be based on the number of electrons in the neutral state. In the neutral state you have 14 electrons, so you'll choose equal to 14, that means it will be 2 1 2 1, right? 2 1 2 1. 14 is for neutral, 2 1 2 1. Usually students select here 1 to 2 1. This is 2 1 2 1. Why? Because here neutral state is N2, which has 14 electrons, right? Here what you have, this is O2, this is O2 positive. O2 is having 16 electrons, O2 positive is 16 minus 1, that is 15 electrons, right? Now in both the cases you have greater than 14, so it will be 1 2 2 1, 1 2 2 1, right? Now always remember that out of these total electrons, always here how many electrons will be filled? K star. How many electrons? 1 2 3 4 5 6 7 8. 8 electrons are already filled in K star, okay? 8 electrons guys that are already filled in K star. So here out of this 14, 8 electrons are already filled. You are left with how many electrons? Here also 8 electrons are already filled. Here also 8 are already filled. Here also 8 are already filled. 8 is filled in K star, right? 15 minus 8 will be 5, 6, 7. 14 minus 8 will be 4, 5, 6. 16 minus 8 will be 6, 7, 8. 5, 6, 7. Okay, so now based on this you have to fill the electrons. 1, 2, 3, 4. Degenerate orbitals are firstly singly filled, then doubly filled. 1, 2, 3, 4, 5, 6, 7. Achha, 5, 6. 1, 2, 3, 4, 5, 6, 7. Right? Here it is 1, 2, 3, 4, 5, 6, 7, 8. Here 1, 2, 3, 4, 5, 6, 7. Right? Now if you see this here, they are asking you what is the number of unpaired electron in the highest occupied molecular orbital. number of unpaired electron, here it is 0 unpaired electrons, 0, right? In N2 positive, acha, they talked about N2 positive, I discussed N2 negative. N2 positive, beta, it will be 13 electrons. Wait a minute. 14 minus 1, that means it will be 13 electrons. So here you will fill it like this. This will be 13 electrons, means 13 minus 8 means how many? 3, 4, 5. So it will be 1, 2, 3, 4, 5. Highest molecular orbital is this one. Here my highest molecular orbital is this one. Here highest molecular orbital will be this one. Here highest molecular orbital will be this one. Right? Highest molecular orbital of the following species. So this will be 0, this will be 1, 0, 1. Here it will be 0. O2 will be 0. Here also, wait a minute. Highest number of unpaired electrons. So there we have 2 and there we have 1. And so there are molecular orbitals. They are asking just simple molecular orbitals. They are not saying bonding molecular orbital, anti-bonding, right? So here highest level is this one, right? So here you have 2 electrons, right? Here highest level is this one. So here you have 1 electron. Here highest level is this one. Here you have 1 electron. Here you don't have, you have 0 electrons. Unpaired electron is 0. So it will be 0, 1, 2, 1. 0, 1, 2, 1. A is going to be the correct answer here, right? So 1 is going to be the correct answer here, right? Okay, everybody, tell me. Is that clear to all of you or not? Is that clear? Right, everybody? Everybody in the chat box, is that clear? Which our notes will be given to you in the description box, okay? Now let's talk about coordination chemistry. Let's talk about coordination compounds, right? And here you have again 2 major topics. One is VBT, based on which shapes, hybridization, magnetic moment is asked. Then there is CFT, from where the questions are asked. Okay, so let's talk about that, right? So first is VBT. That is based, that will tell you the shape, hybridization, geometry. This says that metal and ligand, metal is electron donor, ligand is, ligand is electron donor, metal is electron acceptor, and they form a coordinate covalent bond, right? And when they form a coordinate covalent bond, they go through valence bond theory. Valence bond theory means they, based on the coordination number, they will give the shape. For example, the coordination number is 4, it will be sp3, right? Or it will be dsp2, right? If it is sp3, it is going to be tetrahedral. If it is dsp2, it is going to be square planar. If the coordination number is 6, 5 you will not have, right? If it is 5, it is definitely trigonal bipyramidal. That's why it is not asked, okay? So if the coordination number is 6, either it can be sp3d2 or it will be d2sp3. Here d2 is outer, so it is outer octahedral, and this one is d2 is inner, so it is inner octahedral, right? So these things are there. Now let's talk about that. What are the, firstly though these are the examples, but we will get to understand this better when we do the questions, okay? So these are the examples that you should know. sp hybridization, these are simple, where you have coordination number 2. You don't even need to think about it, right? sp2, when you have simple HgI3 type of coordination number. Now these are important, this one is important, right? In case of tetrahedral, right, these are the examples. Square planar, these are the examples, right? Then for coordination number 5, either it can be DsP3, right, or it can be sp3d2. These are the examples. D2sp3, these are the example. sp3d2, these are the examples. Now what they ask you in the exam is this part and this part, right? Okay, so let's see that how do you answer these questions, right? Okay, let's see how do you answer these questions. That for that we'll have to firstly see strong field and weak field ligands. Actually this theory I have taught you in when I taught you in detail part, I have told you that how strong field and weak field ligand was not invented in VBT, but now we apply it, right? So we will see the application part, right? How do we apply it? So firstly you should know what are the strong field ligands, like NH3, EN, CN, CO, these are strong field ligands. What are weak field ligands? These halogens, water, these are weak field ligands, right? So that you should know. Then you should know that this I'll talk about later, right? Firstly I'll just tell you how to do this, right? For example, some compound is given to you. Now we know that here coordination number is 6. It means either it can be sp3d2 or it can be d2sp3. These are the two possibilities that you will have, right? So first thing is to find the oxidation number of this center metal atom. So this you will find x plus 0 is equals to plus 3, because here this is neutral, right? So it is x is equals to plus 3. Then you will have to find the electronic configuration of this center metal atom. So cobalt is plus 3. Cobalt exists as what? Cobalt is nothing but what is the electronic configuration of cobalt? It is argon 4s 2 3d7. That is the electronic configuration, 4s2 3d7. And 3 electrons when you take out, then when you take out 3 electrons, cobalt 3 positive is 3d6. This is how it is. Now if you have a strong field ligand, this NH3 is actually a weak field ligand here, because here it is a weak field ligand, that is why no pairing will take place and hence it will be as it is, right? So no pair, wait a minute, NH3. In case of cobalt, yes, it's a strong field ligand. It's a strong field ligand. Yes. NH3 in case of copper, it behaves like a weak field. Yes. Otherwise, it's a strong field ligand. So because it's a strong field ligand, it will cause pairing here. And when it causes pairing 1, 2, 3, total 6 you had, it will be 6 electrons. Now you are left with D2sp3. In VBT, you are looking for vacant d orbitals, right? So D2sp3 will be the correct answer. That will be the hybridization here, right? Okay, and that is why it's an octahedral. And why it is diamagnetic? Because no electron is unpaired here. That is the reason it is diamagnetic in nature, right? Okay. Then you have inner. Why it is inner? Because it is D2sp3, right? The complex is called an inner octahedral complex. Now why it is low spin? Low spin because the number of unpaired electrons are less here. That is why it is called as low spin complex, right? Okay. Now based on the number of unpaired electrons, you put here, you put the n value here, you can get the value of dipole moment, I am saying magnetic moment as well. You know, if the unpaired electron is 1, magnetic moment will be 1.7. If it is 2, it will be 2.8. If it is 3, it will be 3.8. If it is 4, it will be 4.9. If it is 5, it will be 5.9. Okay, that is going to be the answer. Is that clear, everybody? Is that clear? Tell me everyone in the chat box, is that clear or not? Right? Okay. Acha, now let's see this one. Again, coordination number is 4. First, you will find the oxidation number. So it is x minus 6 is equals to minus 3, x is equals to plus 3. Cobalt plus 3 is nothing but it is 3d6. Right? Now because this is a weak field ligand, so it will not cause any pairing. So it will remain as it is. It will remain 1, 2, 3, 4, 5, 6. No pairing will be there. That is why sp3d2 is the hybridization, because it has number of unpaired electron and that too 4 unpaired electrons. That is why mu will be 4.9, right? So answer of mu is going to be, it is paramagnetic in nature with dipole moment, magnetic moment 4.9, right? Why it is outer? Because outer d orbitals are used here, and that is why, because of high unpaired electron, it is called as high spin complex, right? Okay. No beta, this does not come in atomic structure, which this is a theory of coordination chemistry. Yaar. Electronic configuration is there in atomic structure. Okay. So let's talk about this particular. These are the kind of questions that they ask you from here, right? These are the kind of questions, guys, that they ask you from here. If you see this, right? This is nickel, carbonyl 4, nickel, Cu4, 4 coordination number is there, right? Based on this, you have to answer. Let's see, right? So one by one, we'll see that. First is nickel. This is carbonyl 4. Now, if you see, this is a neutral ligand, so it will be X plus 0 is equals to 0. So nickel will be in 0 oxidation state. Nickel is atomic number 28, so it will be 4s2 3d8. No oxidation number is there. So now we know that carbonyl, right? When you have, it's a strong field ligand, it will cause the pairing, right? So what will happen? It's a strong field ligand, it will cause the pairing, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you will be left with sp3 hybridization. As there is no unpaired electrons, so dipole moment will be 0, right? In this case, you have x minus 4 is equals to minus 2, so x will be equals to plus 2, right? That is why nickel plus 2 is nothing but 3d8. Now here you have Cl4, which is if you talk about Cl4, it's a weak field ligand. Wait a minute, right? But yes, it's a very important exception that in case of Ni2 positive, right, Cl, chlorine will behave as a strong field ligand. It will start causing the pairing. And I'll also send you one table in the, I forgot to add it here. I'll send you one exceptional table, the table of exceptions in the Telegram channel, where it is written that where some exceptions are there. Like here Cl negative, which is a weak field ligand, is behaving like a strong field ligand. So that is the exception here, right? That is why they have asked this in PYQ, right? So that will cause the pairing and it will give rise to dsp2, and that is why this theory was a failure, because there were so many exceptions in this theory. That's why this theory came out to be as a failure, right? Then you have NiCl4 2 negative. This is nickel 2 positive when you have it, right? Now, wait a minute. Cn, oops, my bad. This is not under the exception, yes. Wait a minute. That's what I was thinking, that this was not under the exception, but still I was doubtful that maybe I forgot about it. Yes, this is not under the exception. I think it is with platinum. I think chlorine is behaving as a strong field ligand. With 4D and 5D series, it start behaving as a strong field ligand, not with nickel. Yes, with platinum, it's behave as a strong field ligand, right? So here, this is Cn, right? And that's why it's a strong field ligand, and that is why it will cause the pairing. You will have dsp2 as the answer. In this case, you have a weak field ligand, it will not cause any pairing, and hence you will have 1, 2, 3, 4, 5, 6, 7, 8. You will have 2 unpaired electrons, so magnetic moment will be 2.8, right? In this case, you have manganese. This will be x minus 4 is equals to minus 2, that is x is equals to plus 2. Now, manganese plus 2 is nothing but it is 3d5, right? Now, in this case, manganese plus 2 is 3d5, right? Now, if you see Br, which is a weak field ligand, right? Manganese is 25, right? Manganese is 4s2 3d5. Manganese 2 positive is 3d5, right? So when you have weak field ligand, it should not be like this. There are some mistakes here, guys. Let me just clear this, right? This is not correct. Let me just clear this. This will be 1, 2, 3, 4, 5. This will be total 5, 1, 2, 3, 4, 5. Okay, yes, it will be like this. It will be sp3 hybridization, right? Okay, and here because the number of unpaired electrons are 5, so magnetic moment will be 5.9. Okay, just put 0.7, 0.8, 0.9 and you will get the answer. So answer will be C is the correct answer here, right? Okay, now let's talk about CFT, everybody. Let's talk about CFT. Crystal field theory. Let's talk about CFT, everybody. Let's talk about CFT. Yes, very good. So in case of CFT, now we consider this as electrostatic interactions, right? We say that in case of octahedral and tetrahedral, splitting of these orbitals are there, right? So what exactly happens here in case of, first if you talk about the orbitals, right? dxy, dyz and dxz are between the axis. Dx square minus y square and dz square are along the axis. So in case of octahedral, what happens? Along the axis, see octahedral is also, if you see the octahedral shape, this is also along the axis, this is also along the axis, and dx square minus y square and dz square is also along the axis. That is why their energy is increased because of repulsion, and hence they are high in energy and less in stability. dxy, yz and dzx, they are decreased, their energy is decreased and they achieve the stability. So that is the reason this give rise to octahedral splitting, right? So this is crystal field splitting is there. This is called the barycenter. From the barycenter, this is called Eg, this is called T2G. G means gerade, gerade means symmetry, right? So in case of T2G and barycenter, the difference is minus of 2 by 5 delta naught, and there it is plus of 3 by 5 delta naught, right? In case of D4 complexes, right, if you talk about, two things are possible. Wait a minute. Let me just firstly talk about tetrahedral splitting here, right? Yes. In case of tetrahedral splitting, it is opposite. dxy, dyz and dzx, they are increased, and dz square and dx square minus y square is lower in energy. It is opposite. Here you have T2 and here you have E, right? Okay, and G is not there in case of tetrahedral. So when you talk about weak field ligand, less splitting is there. That is why pairing energy is greater than delta O. That means because of less splitting, weak field ligands, right, will not cause pairing, because the delta O that is released is less than the pairing energy that is needed. That is why weak field ligand will never cause pairing, because pairing energy, money needed is more in case of pairing energy, and that we don't have. But in case of strong field ligands, crystal field splitting is very high, the gap is very high. Because of this gap here, the delta O will be very high as compared to pairing energy. So pairing can take place because we have enough energy. For example, you have 100 rupees and you want to purchase something of 20 rupees. You can purchase that. For example, you have 10 rupees and you want to purchase something of 20 rupees. You can't purchase that, right? Okay, so same thing is there. Right, now let's talk about spectrochemical series that will define the how much splitting will be there in which ligand. So this is the order of crystal field splitting energy: CO, CN, EN, NHE, EDTA, and SCN, water. This is oxalato, this is OH, fluorine, sulfido, chlorido, SCN, Br, I negative. This is the order of crystal field splitting, right? Okay, now let's talk about this question here, that is two complexes. Now this particular question, if you see, is actually based on the color, right? Two complexes, this and this, are violet and yellow colored respectively. The incorrect statement regarding them, right? Okay, let's talk about that. Now here they have related these two compounds where this is water, this is NH3, which will have higher spectrochemicals, which is higher in spectrochemical series. If you see, NH3 is higher in spectrochemical series as compared to water. So here splitting will be more. Delta values, and they are calculated from energies of violet and yellow color respectively. Both are paramagnetic in nature. They absorb corresponding to their color. Delta value of A is less. So firstly, let's talk about delta value. So definitely delta value of A is less than B, that is true, right? Okay. Then both are paramagnetic, that we have to find out. See, this is a weak field ligand. This is a strong field ligand. Both are existing in X plus 0 is equals to minus 3. So it is, it will be plus 3, yes, right? So both are chromium plus 3. Chromium is nothing but 4s1 3d5. Chromium plus 3 is nothing but it is 3d3, right? So here you have unpaired electron, both will be paramagnetic. See, if you cause the pairing, even then it will be unpaired. If you don't cause the pairing, even then it will be unpaired, right? Both absorb corresponding color to their complementary colors. Yes, always it is done. Delta value of A and B are calculating from the energies of violet and yellow color. No, delta value is calculated from the splitting, the spectrochemical series, how much splitting is there. It is calculated from there. So this particular statement will become incorrect here, right? See, they have asked this question, statement based question based on CFT, right? Okay, tell me bacha. Now I'll do some questions, let's do firstly block chemistry and then I'll give you the break, okay? So block chemistry, now I'm giving you some important exceptions, that because very less is there to teach you. So that's why I'm going to give you break after this, so that we can start with physical chemistry after this. And we'll cover our physical chemistry maybe in next 2 hours, I think so, right? After completing physical chemistry, then we are sorted, right? Okay, so let's firstly finish block chemistry here. See, in block chemistry, first thing is you should remember the oxides here. What are basic oxides, acidic oxide, neutral oxides. Based on oxides only they ask you the questions, right? Okay, otherwise block chemistry is a big thing, right? But now I'm going to tell you some of the specific things that they ask you from block chemistry. First is the nature of oxides, basic oxides, acidic oxide. Basic oxides are of metal, acidic oxides are of non-metal. Amphoteric oxide like aluminium, zinc, vanadium, chromium, lead, tin, these are forming amphoteric oxide. Neutral oxides are like CO2, NO, N2O, and you have H2O. These are having neutral oxides, right? And they also ask you this. Now, if you talk about the exceptional trends here, these are some of the very, very important exceptional trends that you must remember. First is from group number 13, you have atomic radius, right? It should be Bal, Kai, Indian, Te. That means down the group radius should increase. So it should be like this. But in reality, this reverses. Why? Why this will reverse? Because always the answer is going to be inert pair effect. Poor shielding effect of d orbital or poor shielding effect of f orbital, that is always going to be the answer here, right? So here, because of poor shielding of d orbital, this is the effect here. This is the correct order here. Then guys, ionization, this is again a very, very important and very, very repeated exceptional trend. Note these trends here. This is exactly like totally chaotic trend. Firstly boron, then thallium, then gallium, then you have aluminium, then indium. So you can remember it like this, okay? So this is BAlGaInTl. BTlGaAlIn, right? So that's how from this W you can remember this, right? This is very, very important. Then electronegativity order, it's not very frequently asked, but right now they have started asking you this. And exceptional trends, right now they are asking you from the match the following. Like in one question they will ask you like 4 trends. That is how right now is the trend, right? So you will see in JEE 2025 they have asked questions from exceptions. In one question they have asked 4 exceptions, right? So that's why I am directly giving you these exceptions here, right? Okay. Then you have from group number 14, this is simple trend, right? This is no exception here. Here you have exception. This is the exception that you have. In case of ionization energy, the exception in group number 14 is this one. That's why I am telling you that these 2 exceptions are the main important exceptions. This is most important exception, right? This is still they have asked this also they have asked you that the electronegativity of silicon, germanium and tin is same. That is I think 1.6 or 1.8 it is mentioned in your NCERT, right? Then if you talk about trends of group number 15, what they ask you, first thing is you should always remember that stability of lower oxidation state increases down the group. Okay. So group number, what is lower oxidation state? If you have NS and NP, the number of electron in S and P will give you higher oxidation state. Number of electron in P will give you lower oxidation state. So here if you see, this is going to be NS2, NP3. So the oxidation state of +3 increases down the group, like N3 positive, then P3 positive, then AS3 positive, SB3 positive, Bi3 positive. Lower oxidation state stability always increases down the group. +5 oxidation state will always decrease down the group, right? Here I am talking about group number 50, right? And then thermal stability of NF3, then you have NCl3, then NBr3, then I3, right? These are some of the repeated things that they have asked you. Now if you talk about, here what about -3, ma'am? Why it is decreasing? Because electron negativity is decreasing here. That is why -3 state is decreasing, right? -3 oxidation state is decreasing. In group number 16, -2 oxidation state will decrease, right? And here lower oxidation state will be, this will be NS2NP4. Lower oxidation state will be 4, higher oxidation state will be 6. So +4 oxidation state will increase down the group. Okay? And +6 oxidation state will decrease down the group, right? Thermal stability, this we have discussed, and for hydrides of water, hydrides of oxygen family, also it decreases down the group. Electron affinity, if you say, that also follows a very weird order here. Firstly, sulfur. Now, electron affinity means to gain the electron. Electron affinity should decrease. This is also a very, very important thing. Electron affinity should decrease down the group. General order is that down the group, atomic size increases, ionization enthalpy decreases, electron affinity decreases, electron negativity decreases. That is the general trend. So it should be oxygen, sulfur, selenium, tellurium, polonium. Oxygen should have the maximum electron affinity because it has maximum electron negativity in the group. But why it is on the last part? Reason being because oxygen is very small and it already have 2 lone pairs, so electron repulsion are there. So the house of oxygen is very small. It is not able to, it is electronegative, but this is not able to accept the electron. So electron affinity is less. That is why this is the order. Okay. That is the reason this is the order is what you have. Okay. Right, everybody. Now trends of group number 17, very important trends. This is very important. This trend is very important here, right? Very important trends. Very important trends. See, electron affinity again, it should be fluorine, bromine, iodine. But what happens here? These two trends are very important, guys. They are repeated again and again, right? So fluorine, chlorine, bromine, iodine, that should be the trend. But what happens here? Fluorine is shifted to this place because again fluorine has very small size, and because of electron repulsion it is not able to add more electrons, so electron affinity will be decreased, and that's why this is the exception. Bond association energy. Bond association energy again should be highest in fluorine, then chlorine, then bromine, then iodine. But why fluorine has, instead of fluorine here, it has shifted here? Because again the reason is fluorine, it has the smallest size, so the bond should be stronger, right? And bond association energy should be very high. But what happens? Because of its small size and its 3 lone pair electrons, 3 lone pairs, total it has 6 lone pairs. Electron repulsion is very high. That is the reason, because of this repulsion, this bond becomes very less stable. That is why bond association energy decreases. Energy is not required to break this bond, right? Okay. Then thermal stability. We know that down the group the size of fluorine, chlorine, bromine, iodine increases. That is the reason thermal stability of HF is very high, because the strength will be very high, because the size of fluorine end with hydrogen is same. Fluorine, then you have chlorine, then you have bromine, then you have iodine. So that is the reason what will happen, the strength of the bond will decrease. Acidic strength means the ability to donate hydrogen here. So acidic strength will be in the opposite order because it has very good strength. So that is why it is not able to donate H positive. So acidic strength will be least. Right? Okay. Then guys, very important thing that is right now is the trend that they ask you from DNF block. Please do these reactions of K2Cr2O7 and KMNO4. Okay. Chalo. Beta, I have only discussed the important ones, okay? I have only discussed the repeated ones, right? Okay. Group number 15, I have not discussed. I have discussed here, beta. The important ones I have discussed, right? Okay. Chalo. Now let's talk about potassium dichromate, potassium permanganate. First thing is preparation. Now this I am giving you for homework, right? Guys, the preparation of potassium dichromate. First thing is you should know that this ore is called as chromite ore. The question last year only, JEE 2025, they have asked you question based on this chromite ore. So this is chromite ore, right? When you react chromite ore with Na to sodium carbonate, you have the formation of sodium chromate. Then sodium chromate is reacted with acid to form sodium dichromate. Then sodium dichromate is reacted with KCl to form potassium dichromate, and that's how you have the formation of potassium dichromate, right? Then the properties is that it is orange color crystals and they are soluble in cold water, right? Now very important thing is that dichromate, when you add water, this is converted to chromate, that is CrO4 2 negative, right? So in aqueous solution, dichromate and chromate ion exist as follows. So this is dichromate and chromate ion exist in the aqueous medium in the equilibrium, right? In alkaline medium, equilibrium shifts forward, forward direction, solution is yellow. That means if you have alkaline, in this case pH is greater than 7, in this case pH is less than 7. That means in the basic conditions chromate ion is formed, in acidic conditions dichromate ion is formed. Okay, in acidic medium equilibrium is in the backward direction, that means dichromate ion is formed, right? Now it is a strong oxidizing agent. When in its oxidizing properties, now it is acting as an oxidizing agent in the acidic medium, because in basic medium dichromate ion is not existing, only chromate ion is existing, right? So in the acidic conditions, this dichromate ion is converted to Cr3 positive, right? And it will give you these reactions here that they have asked in like multiple questions. I negative to I2, H2S to S, SN2 positive to SNF4, Fe2 positive to Fe3 positive, right? Then you have potassium permanganate. Here the preparation is, you have pyrolusite ore, that is MnO2, that reacts with with a base, that is converted to manganate ion. Now in the manganate ion, that is actually green in color, in the electrochemical oxidation, that is converted to MnO4 negative, to the MnO4 negative, that is the potassium permanganate. And if you talk about another way of converting this, in acidic or neutral medium, manganate ion disproportionates to give permanganate ion. This manganate ion, this MnO4 negative, that gives rise to permanganate ion, that is MnO4 negative, right? Two ways. This is the first step, that is pyrolusite ore is converted to manganate ion, right? That is green in color. Now second step, either you can do this or you can do this. Either you can do electrochemical oxidation converted to permanganate, or you can do in the acidic or basic medium, this is converted to permanganate ion, right? Both the reactions are possible here. Either way you can form this. Again, this is a dark purple, almost black crystal solid. Now here in acidic medium, permanganate ion is converted to Mn2 positive, right? And it oxidizes I negative to I2. This is very important. Other reactions are same. But in faintly neutral alkaline medium, permanganate ion is converted to MnO2 and it oxidizes I negative to iodate ion. This is very important. That in acidic medium it converts I negative to I2. In neutral or alkaline medium it converts I negative to iodate. This is very important, okay? Right? Okay. Tell me. Is that clear, everybody? Tell me. Acha. Now let's see question here. Given below are the oxides Na2ASO3, NO2, NOClO7, amphoteric oxides you have to tell. See, this is acidic, no, sorry, this is basic oxide, this is amphoteric, this is acidic, this is not acidic, these two are neutral, this is acidic. So amphoteric is this one, that is only one, that is AS2O3 is amphoteric in nature, right? So answer will be 1. Then, acha, this is again one of the questions that is very frequently asked to you, that is regarding isoelectronic species. Okay. In this case, size variation is asked to you. Always remember, size is directly proportional to charge on anion and inversely to charge on cation. Okay. Okay. So if you say their isoelectronic means if the number of electrons are same, like in all these cases you have 10 electrons, you can calculate that as well. More the charge on an ion, more will be the size. More the charge on cation, less will be the size. So answer will be A is the correct answer here. Right? Okay, that's how directly you can tell the answer here. Okay, and by that we have also covered inorganic chemistry. Okay, we have also covered inorganic chemistry. Now everybody do let me know in the chat box how much time break you need. We are going to start physical chemistry after this. Tell me how much break you need. How much break you need? Yes, everybody. How much break you need? Yes, students. Let's see how many likes. I think by now it should be 300 plus likes. Let's see how much you have given. 280, very 20 more likes for 300. Right? 20 more likes for 300. I had 30 minutes break. 20 minutes break. 5 minutes, so beta, there is not even, I don't even consider it as a break. Chalo, I'll see you all at 10, up to 10. Chalo, what I'll give you 20 minutes break on average I am giving you, right? So at 10 p.m. I'll see you all, right? And before going, I'm again telling you in the description box right now, guys, you have discounted price of PYQ's book, that is physics, chemistry and mathematics book, that is right now available to you at 1398, right? The price might increase anytime soon, right? So festive season is also over now, right? The price will increase anytime. That's why I'm telling you, after this it will not be available at a discounted price. So the link is in the description. Go and purchase that, because right now is the best time to solve previous year questions, right? Okay, yes. So I'm gonna see you, it's 9:40. I'll see you all at 10 p.m. right? Class will resume at 10 p.m. So I'll see you all at 10 p.m. right? By that time you can have your dinner and you can relax a bit, and after that we'll do physical chemistry, right? So see you all after the break. Hello, yes everybody. Yes everyone, I am back. Everybody, do let me know in the chat box if I am clearly visible and audible to all of you or not, so that we can start with the next part, that is physical chemistry. Yes students, do let me know in the chat box if I am clearly visible and audible to you. Everybody, how's the energy, how's the Josh, and have you had your dinner or not? Yes. So now we are left with some topics of physical chemistry we are going to do that are the most repeated topics for your JEE, right? Let's talk about that. Let's start with that. Yes, if you're ready, then spam the chat box with green hearts in the chat box, right? One request for class 11, please do inorganic. Yes, okay Abhijit, okay Abhijit, I'll take care of that. Yes, okay Abhijit, I have seen that, I'll surely take care of that, right? Okay, yes. So now let's see this solution chapters. Let's see the solution chapters here. First thing is Raoult's law and Henry's law, right? What is Raoult's law and what is Henry's law? Raoult's law says that wait a minute, it should be this one. The vapor pressure is equals to mole fraction multiplied by the vapor pressure of that component in its pure state. So Pa is equals to mole fraction of A, P naught A, Pb is equals to mole fraction of P, P naught B, and total pressure is equals to Pa and Pb. Total pressure is equals to Pa plus Pb. Pa is nothing but P naught A, mole fraction of A. Pb is nothing but P naught B, mole fraction of B, and that is going to be the answer here, right? So this is going to be the Raoult's law, right? If you talk about Henry's law is when you say that pressure is directly proportional to the solubility. In solubility, we will express it in terms of mole fraction. So partial pressure is equals to Henry's constant multiplied by the mole fraction, right? So that is going to be Henry's law, right? So that is Henry's law and this is Raoult's law. Now if you talk about Raoult's law, based on whether it follows Raoult's law or does not follow Raoult's law, you have ideal, non-ideal equation, positive, negative deviation. Let's talk about that, right? So if ideal solutions are those which follows Raoult's law, non-ideal solutions are those which do not follow Raoult's law, okay? So here what we have, non-ideal solution is also divided into two categories. One is positive deviation, other is negative deviation. Positive deviation is which has more pressure than we expect, right? Partial pressure of each component is higher than the calculated. Negative deviation is when partial pressure of each component is lower than the calculated, that is negative deviation. In case of positive deviation, if this we say is the actual ideal graph, then in positive deviation it will be increased. If we say this is the actual graph, right, of ideal solution, then for negative deviation it will be decreased, right? Okay. Now, in case of positive deviation, the simple way of remembering this is two people who are interacting with each other a lot, right? Then they will not focus in study, so that will become negative for them. So if interactions are high, so in case of negative deviations, interactions will increase, right? And in here, in case of positive deviation, interactions are going to decrease, right? Now in positive deviation, delta H mixing, V mixing is greater than 0, delta H and delta V is less than 0 in case of negative deviation. Delta S, that means entropy is always positive whether it's ideal or it's non-ideal solution. Delta G, that means Gibbs free enthalpy is always negative. It is always spontaneous process whether it's ideal or non-ideal solution, right? So these are the examples where the interactions are decreasing, here interactions are increasing, right? Okay. Based on this, you have another thing, that is azeotropes. In case of azeotropes, we talk about those solutions, right? Binary mixture having same composition in liquid and vapor phase and boils at constant temperature, right? So there are solutions which boils at same temperature. They cannot, because they are boils at same temperature, that's why they cannot be separated by fractional distillation. We cannot separate them by the fractional distillation. Now if you see, we have two kind of things. One is minimum boiling azeotrope, then there is maximum boiling azeotrope. Minimum boiling, now always remember that vapor pressure is inversely proportional to boiling point. If positive deviation is there, vapor pressure has increased, boiling point will be decreased. That means boiling point will be minimum. So for positive deviation, boiling point will be minimum. So it's minimum boiling azeotrope. For negative deviation, because pressure has decreased, so boiling point has increased, so it is maximum boiling azeotrope, right? So examples are with this composition, alcohol and water. Here example is HNO3 and water. Now all the examples of positive deviation are the examples of minimum boiling azeotrope. All the examples of negative deviation are the examples of maximum boiling azeotrope. Okay, that you should remember. Right. So right now they don't ask you questions from positive negative deviation, rather they ask maximum minimum azeotrope. That's why I am giving you this relation here, right? Okay. Then guys, we have colligative properties, from where definitely you will see question in the exam. Like definitely you will see one question in the exam based on colligative property. What is colligative property? Where the property is dependent upon number of solute particles that is used, right? So there are majorly 4 colligative properties. First is relative lowering in vapor pressure. So in these cases, we talk about adding non-volatile solute, right? That means the one which does not form vapors, right? So when you form non-volatile solutes, when you add non-volatile solute into the solvent, because it is not volatile, less vapors will be formed, and that is why vapor pressure will decrease, right? And hence what we say, relative lowering in vapor pressure, that means vapor pressure of solute minus vapor pressure of solution divided by vapor pressure of vapor pressure of solvent is equals to mole fraction of solute. That is directly proportional to number of moles of solute. That is the reason it's a colligative property, right? Then you have elevation in boiling point. Now we know that boiling point and vapor pressure are inversely proportional. Because vapor pressure has decreased, boiling point will be increased, right? So that is why we have elevation in the boiling point. And one more way you can understand this, let's say initially, what is boiling point? Boiling point is the point where vapor pressure of that solution or solvent matches the atmospheric pressure. Let's say this is the atmospheric pressure, this is the atmospheric pressure, let's say this is the atmospheric pressure. Firstly, vapor pressure is this much. This is the vapor pressure of solute. This much temperature is required, so this is the boiling point. When you add solute, this will be the vapor pressure, sorry, my bad. This is the atmospheric pressure. Firstly, let's say this is the vapor pressure of solvent, okay. This much temperature is required, this is the boiling point. Now vapor pressure has decreased, now this much is required, this is the temperature, that means this is the boiling point. Now boiling point earlier was this much, now it is this much. So now that means the boiling point has increased, right? And the formula is delta TB is equals to KB into molality. What is molality? Molality is, I will just write it down here. Molality is weight of solute molar mass. This is weight of solvent. This is multiplied by 1000. This is molality, right? And what is this KB? This is called as elevation constant, or this is alebbioscopic constant. which is R into, now based on this formula as well, they ask you questions in the exam. So you should remember this formula as well. This is TB, that is the boiling point of solvent. This is delta H of vaporization, right? And similarly, you have depression in freezing point. Now see, freezing point is the point where vapor pressure of that solvent becomes equal to vapor pressure of frozen solvent. Vapor pressure of which solvent will be high? Vapor pressure of liquid will be higher than vapor pressure of solid. So this is a vapor pressure of liquid, this is a vapor pressure of solid. When this vapor pressure of liquid matches the vapor pressure of solid, that is the freezing point. This is a freezing temperature. Now vapor pressure earlier is this point, right? Now this vapor pressure, this is a vapor pressure of solvent, this is decreased. Now this is a vapor pressure of solution. Now this much temperature is required, this is the freezing point. So that means freezing point has decreased here, right? So now again the formula is same, delta TF is equals to KF into molality. Molality has the same formula, and KF is the cryoscopic or molar depression constant that has this formula. Okay, right? Okay. Yes, right, tell me, is that clear? Why elevation of boiling point, why depression of, now one more thing to remember, that delta TB, now tell me, elevation means TB is greater than TB naught, so it is TB minus TB naught, but delta TF is TF naught minus TF. It will always be greater minus smaller. So TF naught is a greater value as compared to TF, right? So that is why this is going to be the value here, right? Okay, solution should be removed by NTA. And this is easy chapter. This is actually a scoring chapter. Okay. Now, if you talk about the fourth colligative property, that is osmosis. Osmosis is the spontaneous flow of solvent particles from solvent side to solution side, right? Solvent particles are moving from solvent to the solution side. Solvent side, solution side. Solvent side means which has high concentration of solvent, and solution side means which has low concentration of solvent, right? Now remember this thing. How do I show that here? Let's say you have a thing that is, this is the beaker, right? This is NaCl plus water. This is only water. Firstly, solvent to solution side means this is the osmosis. This is solvent, particles are moving from solvent to solution side. Osmotic pressure is to stop the osmosis, the external pressure that you apply. Excess pressure must be applied to prevent passage of solvent particles through semi-permeable membrane. This is the membrane from where they are passing. Solute particles are bigger, so that's why they are not allowed. Then reverse osmosis is when you apply so much pressure that solvent particles are now moving from solution side to solvent side, right? If external pressure is greater than osmotic pressure, the flow of solvent molecules can be made to proceed from solution to pure solvent, and that is also the process that is used in desalination, or it is also the system of reverse osmosis in RO. In our home we have RO, this system is used there, where reverse osmosis will take place, right? Okay. Acha. Now you should remember that here the formula that we use, pi is equals to CRT, where C is the molarity and molarity is equals to W2 by M2 into volume in liters, right? That is the value of molarity, right? Okay. Now let's talk about colligative properties. Acha. Osmotic pressure, three things are there. Isotonic solution is where osmotic pressure is same, that is isotonic solution. When pi 1 is greater than pi 2, this pi 1 which has more osmotic pressure is hypotonic. I should rather write it as pi 1 is less than pi 2. The one which has more higher osmotic pressure is hypotonic. The one which has less osmotic pressure is hypertonic. A solution which has less osmotic pressure than the other solution, that is hypotonic and hypertonic. Right? Okay. Achha, always remember, in case of hypertonic, it will shrink. The cell will shrink. In case of hypotonic, it will swell. How do you remember? Hyper, someone who is so hyper. Why are you getting so hyper? Angry. Angry person will always be like, not happy, right? A hypo means happy person. Hypo person is always like happy. Cheeks are always swelling, right? It's a happy person, right? Acha. Now let's talk about von Hoff factor. Von Hoff factor, that is actually, firstly let's talk about the how it is applied here. Von Hoff factor is actually included in all the colligative properties in front of the mole fraction or in front of molarity, right? What is the formula of von Hoff factor? I is equals to 1 plus alpha by n, that is for association I is always less than 1. For dissociation, I is always greater than 1. Association means dimerization, trimerization. Dissociation means like NaCl is dissociated to Na positive and Cl negative. That is dissociation. And I is equals to 1 minus alpha plus N alpha. That is the formula that you must remember. Right? So for all the electrolytes, we must remember I is not equals to 1. For all the non-electrolytes like urea, glucose, sucrose, I is equals to 1. So that's why we don't use it there. Right? Okay. So let's do this question here, that is, the following solutions were prepared by dissolving 10 gram of glucose. 10 gram of glucose we had, right? In 250 milliliter of water, 10 gram of urea, this of water, 10 gram of this. So mass and volume is same. Osmotic pressure is equals to CRT. This is equals to W2 by M2, volume RT. What is different here? This thing is different. This is also same, this is also same, this is also same. So pi is inversely proportional to molar mass. The one which has more molar mass will have less osmotic pressure. So you just have to check the molar mass here, right? The order of molar mass is sucrose, then glucose, then urea, and opposite will be the order of pressure here. Right, so that's how you will have your answer. A is the correct answer here. Right, so that was a theoretical question. Now let's talk about how they ask you numerical. Numericals are quite simple from solution chapter. Okay, right, let's see that. Yes, everybody. Let's talk about that here. A solution containing 62 gram of ethylene glycol. This is weight, right? W2 is given to you. Ethylene glycol in this much of water, this is W1, is cooled to this much. This is means this is TF, right? If Kf for water is, Kf is given to you, the amount of water separated as ice is what? Right, the amount of water they are asking you, that is separated as ice. Okay, right, let's talk about that. Let's solve this question here. First thing is, guys, we know that delta TF is equals to Kf into molality. Kf is given to you. Now if you talk about the molality here, right, molality is not given to you here, right, but it is 62 by ethylene glycol multiplied by 1000 into 250. Okay? So molality you can calculate it from here, right, and after calculating the answer will be 1 by 0.25. Okay. Now if you see, the freezing point is given to be minus, freezing point is given to be 10 here. Okay. TF naught is given to be 0 degrees Celsius. TF is given to be minus 10 degrees Celsius. So delta TF is TF naught minus TF, that is 0 minus minus of 10, that is 10. So delta TF is equals to 10 degrees Celsius, that you can put here. So this we should not write it like this here. Okay? Delta TF is nothing but 10, right? Okay? From there, once you know the value of delta TF, why we are calculating delta TF from there? Wait a minute, what they are asking you? This much of water is cooled to this much. The amount of water that is separated as ice. How much water is separated as ice? This is what we want to calculate, right? Okay. If you talk about the molality here, wait a minute. The molality is going to be W2 by M2 multiplied by W1 into 1000. Okay. So this is 62, right? And here when you calculate, wait a minute. Let me just calculate this thing here. I think it should be equals to ethylene glycol is 62. So this will be 62 by 62. This will be 250. Right, this will be 1000, this is molality, this will be given to be 100 by 25, that is nothing but 4. So molality is 4 here, right? When you put, when you see this particular formula here, right, in this case, let's say we don't know the value of delta TF, okay? Let's say in this case, we don't know the value of TF, this is 1.86. This is coming out to be 4. So when you multiply this 1.86 multiplied by 4, I am just doing the calculation by calculator so that we do it fast. 1.86 multiplied by 4, it is 7.44. That is correct. That is coming out to the value of delta TF. Right? Okay. So if you have a solution of this much of solute, this much of solvent, right, is cooled to this much, right, which is being cooled to this much, then Kf for the water is this much amount of water separated as ice, right? Then delta Tf is coming out to be this much, right? Now, if you think about that, let's say you have in the question, they have given you delta Tf to be 10, right? In the question, it is given to be 10. That we have calculated here, it is given to be 10. Same formula we will apply. Now we know that molality is equals to number of moles of solute divided by molar mass of, or you can say weight of water, right? Weight of water, right? If we say that it is decreased to 10, this is 1.46, this is given to be 1 because number of moles you can see this is 62, this is also 62 molar masses, so it is going to be 1 only. Now it is coming out to be, now if you see this weight of water after solving this is coming out to be 186 gram, right? Then what we actually did is we had 250 gram of water, out of which 180 gram we have used, right? Then you have 64 gram that we are left with. Right? Okay, so that means answer will be 64 grams is the correct answer. So D is the correct answer here. Right? Okay, that you should remember that same formula we will apply but taking two different conditions here. Right? Here you are calculating the weight of water, right? Putting the same formula, you are getting the weight of water, that is 186 gram is being used if you have freezing point, delta TF is 10 degrees Celsius, right? If this much is used that you already had, then delta TF was coming out to be 7.44, which was not same as this one. That means some extra amount of ice is still left behind, and that you will calculate by subtracting these two, that is 64 grams. Okay, right? Okay guys, chalo. Achha, same direct formula based questions are asked to you here, right? Now let's talk about next chapter, that is electrochemistry. Okay, let's talk about electrochemistry. Achha, see, in electrochemistry, a very famous question that they ask is from Nernst equation. For Nernst equation, firstly let's understand this. 3-4 formulas I'll tell you. Directly based on those formula, they ask you the question. That is delta G is equals to minus NF E naught cell, right? Or you can say delta G is equals to minus NF E cell. F is Faraday, that is 16500. N is the number of electron gained and lost. And delta G is Gibbs free enthalpy. E cell is EMF of the cell. E naught cell is standard EMF of the cell, right? Now, if you have delta G as negative, this will be positive, which means it's a spontaneous. Delta G is positive, means it's non-spontaneous. E will be negative. Delta G is 0, it means it is at equilibrium, right? Now, let's talk about Nernst equation. That is E cell is equals to E naught minus 0.0591 divided by N log of QC, where QC is nothing, that is product by reactants. That is product by reactant. Product by reactant, this we have studied in equilibrium. Product raised to power stoichiometry by reactant raised to power stoichiometry, right? At equilibrium, bacha, E cell is equals to 0 at equilibrium. That's why E naught cell is equals to 0.0591 divided by N log of Kc. That is the relation between E naught cell and Kc. Right? The relation between delta G and E naught cell is delta G is equals to minus NF E naught cell. E naught cell and Kc have that relation. From there you can put this value here, delta G naught is equals to minus NF, right? That was 0.0591 by N log of QC, right? This will cancel and hence you will have your formula here, right? Okay, yes everybody. So delta G is equals to minus NF E naught cell, delta G is equals to minus RT ln K. If you want to write this as, you can also write it like this. Actually, E cell is also, we can also say E cell is equals to E naught cell minus RT by NF log of QC. So when you put E is equals to 0, E naught cell is equals to RT by NF log of QC. This is also the answer. This will be ln, sorry. This will be ln of QC, this will be ln of QC. That's why you have this formula as well. E naught cell is equals to RT by NF Kc. So these are the 3 formulas that you should remember, right? Then you should remember this formula, that is your Nernst equation, right? Okay, tell me bacha, is that clear? These are the formulas that you should remember for sleeping now. What to do here? It will take some amount of time. I will try to complete as fast as possible. A hydrogen gas electrode, this is very important question, right? A hydrogen gas electrode is made by dipping PT wire in a solution of HCl where pH is 10. We will always use reduction here. Oxidation I can find out, I will use reduction. Reduction means gain of electron, right? So here you will have 2 electrons that you will gain, right? So E cell is equals to E naught cell minus of 0.0591 divided by N factor, that is 2. Log of product is pressure of H2 by reactant is H positive square, right? Okay. Pressure is given to be 1, that is given to be 1, right? And this is 0. Electrode standard electrode potential of hydrogen is always 0, whether it's reduction or it's oxidation potential. So this is minus 0.059 divided by 2. This will come forwards here, that will be minus 2, this will be log of H positive, right? This will cancel, you will have minus 0.59, right? This minus of log H positive will be pH only. This will be E cell, right? Now here we know that pH is given to be 10, so E cell, this is reduction, because here I am using reduction, so this is reduction potential. Reduction potential is minus 0.059 multiplied by 10, that is minus 0.59. So E cell of oxidation potential will be 0.59 volt, that is D is the correct answer here. Okay? Tell me, is that clear? That's how. This is actually the most important question, right? Nernst equation is a very important topic, guys. They can ask you question based on like this. If you see for a cell involving 1 electron, that means N is equals to 1 is given to you. E cell is given to you, E naught cell is 0.59. The equilibrium constant for the cell. Now you should know the relation between equilibrium constant and E naught cell, right? So the relation between equilibrium constant here, this will be equals to 0 at equilibrium, right? So it will be E naught cell, it is written here, E naught cell is equals to 0.059 by N log of Kc. N is equals to 1, you will put the value, you will solve it, right, and you will get the answer by taking the antilog. Kc is equals to antilog of 10, that is 10 raised to power 10 is the correct answer here. So answer will be D is the correct answer. Similarly, you can have question based on delta G and E naught as well, right? Okay, now I'll give you very famous reaction these days. A very famous reaction is there these days. I'll just tell you about it. A very famous concept. Usually now they are focusing on this one as well, right? So I'll be writing it here, right? Just give me a second. Okay, so wait a minute, where it was, yes. Acha, if you see this here, right, if you see this, OMG. Okay, see this. See this. Gibbs free enthalpy is conserved. Okay, that is the reason. If you write it in reduction potential where you have decrease in oxidation number, let's say it is Cu positive, then you have Cu simple, right? So what you will write here always, right? How do you write here? So I'll just write 1 here. Okay? See how it will be. Let's see how it is going to be, right? See, for example, this I take, this is E1, this is let's say E2, and this here is E3. Now E3 is not equals to E1 plus E2, but delta G3 is equals to delta G1 plus delta G2, right? Okay. So how do you find it? Here number of electrons is let's say N1, this is N2, this is N3. Here number of electron transferred is 2 minus 1 is 1. Here it is 1 minus 0 is 1, and here it is 2. Okay, number of electrons gained here. Right. Now delta G naught is equals to minus NF E naught cell. So this is E naught 3. This is minus E3. This is minus N2 F E 2 naught minus N1 F E 1 naught. Right. And here what you will have, and here what you will have, you will have E3 naught is equals to N2 E2 naught plus N1 E1 naught by N3. That is what they ask you these days, right? This is very important, that delta G is conserved, but electrode potential is not conserved. Okay, this is a very important thing that right now they are asking you. And I would always advise you to write it in reduction potential, because otherwise students do mistake in plus and minus, right? So always make it in your head that always I am going to solve reduction potential. If they ask oxidation, I'll just do the opposite of that, right? Okay, this is how I don't let myself get confused, right? Now guys, let's talk about the next thing, that is chemical kinetics. Let's talk about that. Acha. In chemical kinetics, firstly we'll talk about that 3 orders mainly we have, like 0 order, first order and second order reaction. Okay? See, 3 orders mainly you have: 0 order, first order and second order reaction. In 0 order reaction, rate is not dependent upon the initial concentration. First order it is dependent upon rate, concentration raised to power 1. In second order it is dependent upon concentration raised to power 2. Right? In 0 order reaction, these formulas, see, in 0 order and first order, these are 2 important formulas that is important for you, right? 0 order reaction, it is initial minus final divided by time. For first order reaction, rate constant is equals to 2.303 by time divide into log of initial by final concentration. Okay, that's how you should remember this, right? Then see, if you talk about, this is a reaction, let's say this is the order. Now what is the general criteria of rate constant if n is the order of the reaction? That rate constant is equals to mole per liter 1 minus n per second. That is the formula of rate constant. You can put n is equals to 0, 1, 2 depending upon what is the order, and T half is directly proportional to initial concentration raised to power 1 minus n. If you have n is equals to 0, it is directly proportional. If you have first order reaction, it is independent. If you have second order reaction, it is inversely proportional. So you can use these 2 formulas, which are very, very important, right? Okay. Then talking about T half lives of 0 order and first order is very important. So T half of 0 order is, you should know this relation also, that T half is equals directly proportional to initial by initial raised to power 1 minus n. And you should also directly know these 2 formulas. This one you don't need to know, this one and this one you should know. T half is equals to initial by 2k, T half is equals to 0.693 by k. These 2 are very, very, very important formulas, right? These 2 formulas are very important. Then guys, these formulas, these 2 formulas and these 2 formulas, these are some of the very, very important formulas, these 2 formulas. These are, I think chemical kinetics is easiest to take marks from. And always remember, when things are given in percentage, take initial concentration as 100. When things are given in fraction, take initial concentration as 1. For example, here the rate constant for first order reaction is K, the time required for the complete 99%. So see, A naught is taken to be 100 and final concentration AT will be 100 because 99% of the reaction is completed, so it will be 1%. So it will be 1, okay. So K T is equals to 2.303. This is the formula, by K log of initial is 100, final is 1. So it will be 2.303 by K. This is 2, right? So it will be 4.606 by K that is the value of T. T is equals to 4.606 by K, and hence D is the correct answer here. Okay. So that was directly based on the formula. Now another kind of question. This also is another kind of question that I am giving you complimentary, right? Because this is also important. This I have not written in those 34 most important topics. I think I have not written it there that I'll do. But when I was going through this, and I thought that okay, let's do this as well, right? So this is one of the important questions of finding order of the reaction, right? Here what you will do, first you will see the slowest step here. Slowest step is this one, then you will write the rate of the reaction according to the slowest step, right? Now you will see which one is intermediate, the one that is not there in the original reaction. So this one will be the intermediate, because this is not there in the full-fledged reaction. So you have to replace X here, you will replace it from here, you will say Kc is equals to X square divided by X2. So X is equals to Kc multiplied by X2 under root. This is half, this is half. So you'll put it here, you will put it here, you will have R is equals to K. What is the value of X? That is Kc raised to power half, this is X2 raised to power 1 by 2, this is Y2. And this will become a new constant, this is K dash, this is X2 raised to power 1 by 2, this is Y2. So order of the reaction is going to be 1.5 is the correct answer here. Is that clear, everybody? So answer will be C is the correct answer. Right, everybody? Tell me. Is that clear? Okay, so what you have to do, firstly see the slowest step, then replace the intermediate from the equilibrium. Right? Yes. Chalo. Let's ignore them, right? Let's focus on our task. Next is, guys, we have our Arrhenius equation, that is K is equals to A multiplied by A e raised to power minus EA by RT. Right, this is our Arrhenius equation. You can also write it as log K is equals to log of A minus EA by 2.303 RT. Right, this is very, very, very important equation from this particular chapter. Very important equation, right? Okay, when you convert it into ln of K, you will have ln of K is equals to this, Y is equals to, this is mx plus c, where ln of A is the intercept, 1 by t is the x-axis and ln of K is the y-axis. So you will have slope here is equals to minus EA by R. And if you have the same thing here, this derivation I am not going to do here, right? I have done it in detail multiple times. So I'll just directly tell you that this particular formula is also very important for numerical purposes. Log of K2 by K1 is equals to EA by 2.03 R T2 minus T1 by T1 into T2. If it is K2 by K1, this will be T2 minus T1. Okay, very important. Right? Okay, chalo. Now let's see this particular question here, that is the slope of Arrhenius plot, right? ln of K versus this. For the first order reaction is this much. The value of the reaction of EA of the reaction. So they are giving you slope, you just have to compare this. So we have already discussed that slope from this graph is nothing but EA by R. So you'll just compare minus EA by R is equals to slope that is given to you. R value you know, you will put it here and you will get the answer of EA here. Right, R, because everything is given in energy, so you will put the value of R as 8.314. Right? Okay. Tell me, everybody, now let's do the next chapter here. that is atomic structure. Everybody in the chat box, let's do atomic structure. Let's talk about atomic structure. Acha, two major important topics from atomic structures are quantum number and Bohr model of an atom. Very important. Sure shot you will have question based on either of the two, right? Sure shot you will have question based on either of the two here, right? Okay, so just give me a second. Yes, okay, and third one is graphs, है ना? Graphs, I also told you, it's not like they have asked this previously so much. This they have already asking, and this right now the trend is little bit changing towards graph as well, right? So we'll talk about that as well here. So these are the three major topics. First, guys, you have to remember all the formulas, right? The formulas of radius, right? That is r is equals to 0.529 n square by z. This is the formula of radius. This is the relation of radius, where n is the orbit number, z is the atomic number, right? Then you have a formula of velocity, then you have formula of time period, right? All of these are very, very important for you, right? Very, very important. Then the formula of energy here, right? In terms of electron volt, in terms of joules, the direct relation that energy is equals to z square by n square, that also you should know, right? So these relationships and these formulas you should remember as it is. Now you should remember that ionization enthalpy is opposite of the energy of that orbit. You will just have to put minus there. And if total energy is minus x by 2, kinetic energy will be change in sign of total energy, and potential energy will be half of total, will be double of total energy, right? That you should remember, right? Acha, now let's talk about when you calculate all these hydrogen atoms. When you calculate the values of hydrogen atom, what you will observe here, right? You will put n is equals to 1, 2, 3, z for hydrogen atom. I don't know why my pen is literally falling like every single second. So z is equals to 1, right? N will be 1, 2, 3, 4. You will calculate the value of energies here. And these are the values that you will get in electron volt. And you know what you will see? As n increases, the value of energy, can you see here? The value of energy also increases. Minus 13 to 0 it is going. So on the number line it is increasing. And the gap, that is delta E, is decreasing here, right? The gap is higher, then it is decreasing. It will start overlapping with each other, right? That is an important conclusion here. Then guys, we have 5 kind of series here, that is Lyman, Balmer, Paschen, Brackett and Pfund, right? In this case, N1 is fixed, N2 might change. Lyman 1, Balmer 2, Paschen 3, Brackett 4, Pfund 5. And they also have a fixed region to where they lie. Lyman lies in UV region, Balmer lies in visible, Paschen, Brackett, Pfund, they lies in infrared region. That is also very, very important, right? Okay, so Lyman, all the lines that are coming down to n is equals to 1, Balmer, all the lines to n is equals to 2, Paschen 3, Brackett 4, Pfund 5. Okay, the point, the orbit where they are falling is same. Okay, the orbit where they are falling is same, right everybody? Chalo. Now let's see number of spectral lines. How do you calculate? If they ask you the number of spectral lines, that will be n2 minus n1, n2 minus n1 plus 1 by 2, right? Let's say they ask you number of spectral lines from 4 to 1, right? That will be 4 minus 1, 4 minus 1 plus 1 divided by 2. That is 3 into 4, 4, 3, 12 by 2, that is 6, right? And if they ask you 4 to 1, out of 4 to 1, lines in Lyman series. Lines falling in Lyman series. So here what you have to do, select the higher, that is 4, this is n high, and this Lyman will tell you n specific, that is 1. If they tell you lines that lie in Balmer series, from n 4 to 1, lines that specially falls in Balmer series, that means n specific is 2. So in this case, we are telling about all the lines that are falling from 4 to 1. It may be 4 to 2, 4 to 3, 4 to 1, so many lines can be there, right? Now, when we are specially saying that falling in Balmer series, or lines that are lying from 4 to 1 and falling on n is equals to 3, that means n specific is mentioned to be 3, okay? So that's how you will calculate n specific. Right, everybody? Then there is this Rydberg equation that you should remember. Very, very important. That is 1 by lambda is equals to Rydberg constant 1 by n1 square minus 1 by n2 square. Right? So R is the Rydberg constant. R has this value, and if you want to solve 1 by RH, directly you can put this value. Right? These are direct relations that I am telling you here. Now the value of this Rydberg equation may vary here, right? For example, if you see first line, alpha line, minimum energy, minimum frequency, maximum wavelength, that means we are talking about that this is 1 less than that, right? This is going from the next, that means you are going from n1 plus 1 to n1. If you have, that means n2 is equals to n1 plus 1. If you have last line, limiting line, maximum energy, means minimum wavelength you have, right? That means n2 is equals to infinity. Okay? If you have second line or beta line, that means n2 is equals to n1 plus 2. If you have third line or gamma line, that means n2 is equals to n1 plus 3. These are very, very, very important things for you, right? Here they can also write longest wavelength. Here they can also write shortest wavelength. Okay? That way also they can write this. Right, everybody? Tell me. Now let's talk about this JEE 2023 question, very famous question this is. The shortest wavelength. Now whenever you see shortest, means wavelength should be shortest, means energy is maximum. So that means n2 is equals to infinity. That we are sure that n2 is infinity. Of hydrogen atom means Z is equals to 1. Lyman series means n1 is equals to 1. Is lambda 1. The longest means n2 is equals to n1 plus 1, that means it is 1 plus 1, that is 2. n1 is 1 now. Longest wavelength, acha, Balmer series. In case of Balmer series, n1 is 2, so here it will be 2 plus 1, that is 3. This we are taking out as lambda 2. Here Z is given to be 2. Okay? So you will just equate these two things, you will calculate the ratio of these two things and you will have your answer, okay? So you will put this value for hydrogen, you will put all the values, for helium you will put all the values, and you will take the ratio of these two things and you will have your answer, okay? Right, everybody? This is based on Rydberg's equation, right? Tell me everyone, right? Okay? Tell. Yes. Okay. Tell me. Acha, now let's talk about quantum numbers. For quantum numbers, I am directly giving you this very, very simple, amazing page. If you remember this page now, trust me, you will be able to solve quantum numbers quite easily, right? So quantum numbers, we have 4 quantum numbers, n, l, m and n, right? So principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number, right? Principal quantum number is, it can be from 1 to infinity. Azimuthal quantum number will be from 0 to n minus 1. Principal quantum number will tell you the name of shell, then subshell, then orbital, then the spinning of the electron, right? So shell will be from 1 to infinity. In one shell you will have, let's say the shell is 1, so you can have 1s. 1p does not exist. Why? Because L can be equals to 0 to n minus 1. N minus 1 is 1 minus 1, that is 0. So L can only be 0. So 0 means it is S, P 1, wait a minute, 0, 1, 2, 3. So it is S, P, D, S, P, D, F. Okay. So if N is equals to 2, that means L will be from 0 to 2 minus 1, that is 1. So it will be 0 or 1. It means S and P. That's why you have 2S and 2P. If you talk about N is equals to 3, so it will be 0 to 3 minus 1, that is 2. It will be 0, 1, 2. So it will SPD. So it is 3S, 3P, 3D. Okay, so that's how you're going to have this. Then guys, we have magnetic quantum numbers. That is M is equals to minus L to plus L. Right, here it will be M is equals to, for example, L is 0. So it will be 0. If L is 1, so it will be minus 1, 0 plus 1. If L is 2, it will be minus 2, minus 1, 0 plus 1 plus 2. That is why if L is equals to 0, we have S, and that is why for S we have only one orbital. For P, we have 3 orbitals because one is minus 1, 0 and then plus 1. For D, we have 5 orbitals, minus 2, minus 1, 0, plus 1, plus 2. For F, we have 7 orbitals. We have minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. Right? So that is going to be the case here. Spin quantum number is rotation. That means it can be clockwise. It can be anti-clockwise. Okay, the rotation can be clockwise or anti-clockwise. Usually we represent it by this sign, clockwise, anti-clockwise, right? Now the formulas that are connected to this one is number of subshell is n, number of orbital is n square, number of subshell in a shell is n, number of orbitals in a shell is n square. Number of electrons will be 2. In one orbital you will have 2 electrons. In one box you will always put 2 electrons. 3 electrons we never put, right? So number of electrons is 2n square. Number of orbitals in a subshell is 2l plus 1. Number of electron will be 2 into 2l plus 1, right? Angular momentum, this question also they have asked, L into L plus 1 under root h by 2 pi. Spin angular momentum is this one. These are the formulas, right? Okay, understood everybody? Now number of orbitals associated. Now with a graph, now let's not do it here because now you will get confused. That I'll do in some other marathon, right? You can also see that in detail, right? Because I don't think so that is even possible to do now. Yes, we will not do it now, right? I'll just tell you about the formulas because I've already discussed that in detail because I think graphs it should be in more detail, right? In now you guys are also quite tired, right? So I will not suggest you to do graphs at this point, right? Okay. So number of orbitals associated with quantum numbers n is equals to 5. Now n is equals to 5, you have ms is only 1. So n is equals to 5 means number of orbitals in a shell n square, so it is 5 square, so it is 25. So answer will be directly this one. Or you know what you can do, n is equals to 5 means L can be equals to 0, 1, 2, 3, 4, right? So here it is S, P, D, F, G. This can be 1, this will be 3, this will be 5, this will be 7, and for if L is equals to this will be minus 4 to plus 4. So it will be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, it will be 9. Okay? So if you add these things, you will have 25 as the answer. You can do this way or you can directly put in the formula. Right? Okay? Okay, ji? Tell me. Tell me. Acha. One more question right now they are asking is based on radial nodes. Radial nodes are n minus L minus 1. That is the formula of radial nodes. Angular nodes are L and total nodes are n minus 1. That is the total nodes that you have. Okay? Understood? Tell me everybody in the chat box. Tell me everyone in the chat box if that is clear. Okay? Now let's do last 2 chapters here. Let's finish it off. Let's finish the next 20 minutes. I'm going to finish this. Right? I know your battery is also quite low. Right? Let's see. Let's see everybody. Let's finish this off. Let's finish this off now only. Equilibrium. Now here also I have selected some very important formulas. Now in this pH based questions are very important, right? So pH of 2 strong acids, right? So when you have 2 strong acids, H positive of the solution is H positive from acid plus 10 raised to power minus 7, that is from water. If H positive is greater than 10 raised to power minus 6, then you can ignore 10 raised to power minus 7. If it is not greater, then it should not be ignored. Then you have to take this full formula, right? Similarly, if you have strong base, then OH negative will be OH negative from base, the concentration from base plus 10 raised to power minus 7. If this is greater than 10 raised to power minus 6, this can ignore, otherwise you cannot ignore, right? If you have 2 strong acids, then H positive solution will be N1V1 plus N2V2 by V1 plus V2. And what is normality? Normality is n factor into molarity. So you can put here M1V1, M2V2, right? For 2 strong bases also, you will add it N1V1 plus N2V2 by V1 plus V2. That is the formula for 2 strong bases. Now pH is equals to nothing, that is minus log of H positive of solution, right? Here POH is equals to minus log of OH negative of solution and pH is equals to 14 minus POH. That is the value. That is how you will calculate the values of pH here. Now most important is strong acid and strong base. If you have strong acid and strong base, then you will subtract 2 normality volume, right? That means N1V1 minus N2V2 modulus divided by V1 plus V2, that is going to be the value of H positive solution. In this case, if the N1V1 NV value of acid is more, then you will have H positive of solution. If NV value of base is more, then you will have OH negative of solution. Now the value that is more will tell you, that is why this is so important. What I am telling you, N1V1, if NV value of acid is strong, that means we are calculating H positive. If NV value of base is more, that means we are calculating OH negative here, right? Okay. Next guys, we have weak acids. So this is not important. So we are only doing important things. So I'll just delete this one, right? Because see, I know that you are up for here most like 100% sure short topic. So this is not sure short. This is important, right? This is important. So weak acids, that is Ka is equals to C alpha square, right? Just remember this one, that this is for monobasic acid. Mono, that only has one H positive. Then Ka, dissociation constant, is equals to C alpha square. C is the initial concentration. And when you solve this, you will have the answer, that is pH is equals to half of pKa minus log of C. Okay. Now pH values, pH formulas you should better remember for strong acids, strong bases, weak acids. You should remember this for solubility, you should remember this for buffer solution as well, right? Buffer solution for salt hydrolysis, you should remember these formulas are very important, right? Okay. So 50 ml of pH is equals to 1 is mixed with 50 ml of pH is equals to this. The pH of the mixture will be. Now pH of two things are given to you. Here you will calculate the value of H positive. There you will calculate the value of H positive. Here H positive will be what? This will be, if you see this here, right? Minus log of H positive is equals to 1, right? From there you will calculate the value, right? This will turn out to be, when you see log of this H positive will turn out to be 0.1, right? Similarly for pH is equals to 2 means this will be 10 raised to power minus of 2. This means this is 10 raised to power minus of 1, right? So when you put the values here, you will get pH 1 and pH 2, so that is the value, right? So H positive concentration we know, volume of both are given to be is mixed with 50 milliliter solution. That means V1 and V2 both are given to be 50 milliliter. So now H positive of the overall solution will be N1 V1 plus N2 V2 by V1 plus V2. You will solve it. You will get the value of H positive of solution, that is coming out to be 0.055, and minus log of H positive is going to be the pH value here, right? Then you put the value, that is going to be minus log of 0.055, and you will have your answer here, right? Okay, tell me. Done, right? Acha, another question. Now this question is also quite famous. In 2025, they have asked like very simple, very simple question based on solubility product. So it's a very simple concept based on which right now they are asking you questions. In JEE 2024 and 2025, you will see a lot of questions based on this, right? So solubility product is actually the equilibrium constant for dissolution of solid substance in the aqueous solution. So how do you calculate that? If you have a salt like this, then KSP, solubility product, is x raised to power x, y raised to power y, solubility raised to power x plus y. That is the direct formula that you should know. For example, you have CaF2, right? This is Ca2 positive plus F negative. So you can have KSP is equals to 1 raised to power 1, 2 raised to power 2, solubility of 1 plus 2. That is 4s cube will be the value of KSP. That's how you calculate this. And based on this simple concept, they have asked you question, okay? So it's a very important thing. Then there is concept of common ion effect. So in case of common ion effect, what we actually do, this is the ion, F negative is also released from CaF2, and F negative is also released from NaF, which is 0.1. This concentration is given to you in the question. Here it will give 0.1 Na and 0.1 F negative. This will give you, if solubility is S, this will give you S Ca2 positive, and 2S F negative it will give. F negative is same in both the cases, so I'll add 2S here, I'll add 0.1 here, right? Now solubility is very less as compared to 0.1, that's why this is approximately equal to 0.1. So here KSP is this solubility raised to power stoichiometry, that is 1. This solubility, that is 0.1 raised to power stoichiometry, that is 2, and that's how you have this answer here. that is from common ion effect, and this also is very, very, very important, right? Okay, you can see this question here, that is for a sparingly soluble salt, that is the equilibrium constants of this and this are given to you. The solubility product they are asking you, right? Equilibrium concentrations are given. So if you see this here, you have A, this is converted to A2 positive and B negative. KSP is this concentration raised to power 1, this concentration raised to power 2, that is solubility product. Okay, that is concentration of product raised to power the stoichiometry. And this was actually this what I told you, na, this was actually the direct trick to solve this, right? Okay, this is actually to compare KSP with solubility. Here we compare KSP with the concentration. It depends that what is given to you, right? So now here they are asking you the solubility product, that is KSP they are asking you. Put the values here and you will get the answer. Okay, right everybody? Right everyone? Everyone in the chat box tell me. Everyone in the chat box tell me. Chalo. Now we are going to do the last one here, right? I am not even looking at your chats. I know you guys are, I don't know what you guys are doing, right? Fully here and there. Okay, fully here and there you guys are moving. Chalo, let's see thermodynamics. Let's see thermodynamics. Now guys, in thermodynamics you should know the formulas of work in isothermal, isobaric process, isothermal, isobaric, isochoric. Most important is isothermal, reversible and irreversible, right? So isothermal, irreversible, this is isothermal, irreversible, where work is minus P external nRT 1 by P2 minus 1 by P1, right? Okay. And for isothermal reversible, you should remember this particular formula. That is work is equals to minus 2.303 nRT log of V2 by V1 or log of P1 by P2. This is also a very, 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 very important formula for your exam. Like very high chances they can ask you question from this one, right? Okay. Then guys, isobaric, because P is constant, so it will be directly work is equals to minus P delta V. In isochoric, volume is constant, so delta V is 0, so work is also 0 here. In cyclic processes, work done is equals to area enclosed, because it's a clockwise, that's why it will be negative, and for anti-clockwise it will be positive here, right? Okay. Remember that the first law of thermodynamics is different here. In case of chemistry, you have delta U is equals to Q plus W, right? In physics, it's different, okay? Right? Now, I am not asking you to do the derivations, just remember the direct formulas, because in thermodynamics, no direct questions are based on the formulas, right? So, work adiabatic is equals to NCV T2 minus T1, right? Final temperature minus initial temperature, this is NCVM, this is heat capacity, molar heat capacity at constant volume, NCVM, okay? CVM, molar heat capacity at constant volume, right? And always remember guys, QP is equals to delta H and QV is equals to delta U. This is also a very important relation, right? And also do remember that delta H is equals to NCVM delta T and delta U is equals to NCPM delta T. Okay, these are some of the important formulas that I am telling you. From directly formulas they ask you question from thermodynamics, right? This is for irreversible adiabatic, but for irreversible adiabatic, this also you should remember that PV gamma is constant, TV gamma minus 1 is constant, P1 minus gamma, T gamma is constant, right? Now, basically how they ask you questions from adiabatic, let's see that. Actually, mostly though they will ask you question from isothermal reversible or irreversible, or they will ask you either from these formulas, CVM, CPM, based on this they can ask you, directly numerical based. Or now sometimes what they do, they will give you work done, they will give you N, that is number of moles, right? CVM they will give you, right? And then CVM for monatomic, diatomic, this you should know that how to calculate, right? This you have already done in physics as well, right? You already done degree of freedom, all these things in physics as well, right? That's why I have not picked up here in 34 most important topics, but heat capacity is a very important topic. But considering that you have already done this in physics as well, that's why I am not picking that here, right? Otherwise, that is very important for monatomic, diatomic, polyatomic, diatomic linear, diatomic non-linear, calculate the value of gamma. That is very important for chemistry as well. You will calculate CVM from there. They can ask you T2 value, final temperature. This question they have asked you so many times, right? Okay. Then sometimes they directly ask you question from here. If for a monatomic gas, you should know the gamma. For a monatomic gas, you should know what is the degree of freedom, what is gamma. Pressure P1 will be given to you, V1 will be given to you, P2 will be missing and V2 will be given to you. They will ask you what is P2. From there you will see. But they should have mentioned there that it is irreversible adiabatic process. Only then you can apply this. Right? Okay? Then guys, this also is a very, 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 very important equation. Right? Directly, like this also so many times this is asked. Gibbs-Helmholtz equation, that is delta G is equals to delta H minus T delta S. Now, based on this, how they ask you the question? For example, if you have delta H is negative, delta Ts is negative, right? Dekho, let's see, delta G is equals to delta H minus T delta S. If this is negative, wait a minute, this is negative, and this is also positive. So always this is going to be negative only. If let's say this is negative and this is also negative, then this is negative, then this should be greater. Then if you have this overall value as negative, delta H should be greater than T delta S, right? If I say that, because for spontaneous delta G should be negative, right? Now if delta this is positive and this is also positive, then this should be greater, then T delta S should be greater than delta H, only then this process will be spontaneous. For example, let's say this is positive, this is negative, then always it is going to be positive because always it is going to be non-spontaneous, right? So that's why Gibbs-Helmholtz equation becomes a very important concept, okay? Right, everybody? Chalo. Now, let's see one question based on this. For a certain thermochemical reaction, right? They have given you delta H is given, delta S is given. Very interesting. This question is actually combining two things. So, delta G is equals to delta H minus T delta S, right? Delta H is given, temperature is given, this is given, this is given. You will calculate the value of delta G naught here. Now we know from electrochemistry that how delta G is connected to log of Kc. Then you will put the value of delta G here. Then you will calculate the value of log Kc from here. This is from electrochemistry. This is actually from equilibrium as well. In equilibrium also you have seen this particular equation. Right? Okay? So that's how they ask you the question. Now beta, some basic concepts of chemistry na. I'll tell you a simple thing about some basic concepts of chemistry. See, here it's very unpredictable what kind of question they will ask. I am being very blunt here. Stoichiometry, they can combine stoichiometry with organic chemistry as well. That question also they can ask you. They can also do one thing, they can ask you question based on limiting reagent or empirical formula. Okay? So it's quite unpredictable and it's not very important chapter, right? But it's important for your basics because they relate this chapter to organic chemistry as well. They can relate this to other parts of chemistry as well. So you should know that what is happening here. You should know all the concentration terms here. You should know mole fraction. You should know molality. You should know molarity. You should know what is weight by weight, weight by volume, volume by volume percentage. You should know the strength, normality, everything you should know. So concentration terms you should know from here. Then guys, you should know the concept of moles, like that is used throughout your physical chemistry, right? If they ask you directly from this chapter, then it will be slightly on a difficult side question. Like if only based on moles the questions are asked, right? Not a difficult means that will be a different kind of question, right? So you should do your PYQs, every single question of PYQ based on this one. Empirical formula and limiting reagent are quite easy, right? So you can easily solve that, right? Okay, so you'll see moles is actually given weight by molar weight, given volume by 22.4 or given particle by Avogadro's number, right? Now, how they ask you the question, let me tell you two things here. Either if they ask you directly the question, it will be something like this. It can be different from this as well. It can be based on purity, impurity as well. So, I would not advise you if you are looking for a safe score. At this point, my advice will not be, I would advise you go through simple questions of moles, right? Simple questions of stoichiometry, do empirical formula, limiting reagent, that's it. If you're like, I will get full marks in some basic concepts of chemistry and they ask you some new question only from some basic concepts of chemistry. Sometimes based on unitary method only they ask you the question and students are not able to do that, right? I have seen that students find it very difficult, right? Mole concept they find very difficult, right? Sometimes very easy questions are asked, sometimes weird questions are asked, right? So that's why only maximum 1 or 2 questions they can ask you from here, and that too probabilities like only one question will be there if there from mole concept, and if it is easy then I think from this much information you can know, right? So I will advise you do the PYQs from mole concept and that is enough for you, right? Because there is no as such formulas that are there. There is no as such steps that are there, right? So you have to practice a lot of questions here. So on combustion, this much of organic compound containing CHO gave this much of H2O, this much of CO2, percentage of hydrogen, oxygen in the given compound. So here they are saying that you have an organic compound, we don't know what is that organic compound, this much you have, where this much of CO2 and this much of H2O are given. Now the hydrogen that you have here is actually from this one. So if you see 0.127 divided by 0.210 is the percentage of hydrogen here. So percentage of hydrogen is actually the amount that you have here divided by the amount that you have here, right? So let's talk about how much percentage of hydrogen you have here. Let's see. Weight of carbon in CO2, how much weight of carbon is there? 12 by 44 into this. Weight of hydrogen in H2 is 2 by 18 into this, right? What is this? Is a simple na? Weight of carbon in CO2. See, in 1 mole of CO2, 12 gram you have. Okay? That means in 44 gram of CO2, 12 gram of carbon you have. So in 0.307, this is unitary method, guys. This is unitary method. This is unitary method. Then percentage of hydrogen is, percentage of hydrogen will be the amount of hydrogen that you have here divided by the weight of the compound. Percentage of oxygen will be what? You can also do one thing here. Percentage of oxygen, you can also do one thing here. Instead of this now, you can calculate percentage of carbon is 0.0837 divided by 0.210 multiplied by 100. So percentage of oxygen is 100 minus percentage of carbon minus percentage of hydrogen. From there also you can calculate, right? Right? Okay, tell me. ठीक है, so that's how. अच्छा, one more question ना, that I told you that organic and this they can mix here. Okay, I'll just tell you where they can mix this. This was, I think, asked in 2024 or 25. This was asked, right? So this is a mixture, like a very simple mixing of mole concept and organic they have done. They are saying what amount of bromine will be required to convert 2 gram of phenol to 2,4 this tribromophenol. So phenol to 2,4,6 tribromo, how much amount of bromine? So this is the reaction we know, right? We also know that 2 gram of phenol you have. So this is 2 gram. Moles of phenol will be 2 divided by 94. 94 is the molar mass of phenol. So this is 0.021. So what we know, for 1 mole you require 3. For 0.021 you will require 3 into 0.021. Right? And that is going to be the moles of bromine. They are asking you the mass of bromine. So mass is moles multiplied by the mass of bromine, and that's how you will have your answer. Now here students can get stuck in so many ways. They don't know the mass of the bromine. They don't know what is the molar mass of the phenol. Right? So it is actually a very simple question that they have just combined simple mole concept with a reaction. Okay, and these kind of question also they ask you where they combine mole fraction with the reaction, right? Okay, tell me guys. So as I have kept the promise, right, as I told you that I'll complete, right, all the 34 topics that I have mentioned, right? So I have completed that, and that's it, right? Okay, chalo. Thank you, right? So let's see how many likes you have put here and how many hours I have been teaching. Let me see. 6 hours. I think it would be 7 hours now. Yes. Almost 6.5 hours, isn't it? Yes. Chalo. Okay? Now, tomorrow at 5 p.m. Okay, I'll convey your message to Namrata ma'am. I'll convey your message to Namrata ma'am, guys. Okay? Chalo. Okay then, guys. Now I'll see you all in the next class. That is, let's see if I'll take the class maybe on Saturday. I'll see that and I'll tell you about it. I think this week though too much is there. Like you have studied physics, you have studied chemistry. Now tomorrow you're going to study mathematics, right? So you have enough content, right? Chalo. Now, okay then guys, now I'll see you all in the next class. Those who are watching this on the recorded version, do drop your comments in the comment section, and those who were here right till the end, drop down your comments because that values a lot, right? That actually matters a lot to us. And one very important thing guys, for your practice we have this previous year question book, and that is provided to you at 1398, right? Only it is at a discounted price. Physics, chemistry and mathematics, all the 3 books will be provided to you. 143 shifts are there, and if you do that, I think you're good to go. You don't need to have any other book for question practice if you have this book, right? Okay, yes. Okay then guys, I'll see you on the next class. Till then, bye bye, take care, see you all, bye bye, and drop down your comments. I'm waiting for your comments. And yes, MBSAT scholarship program is there. Online scholarship program is going from 21st to 28th of October. So link is in the description. Register yourself because the ending date is soon, right? So register yourself here if you want to get amazing scholarship and amazing gifts like iPhone, iPads, right? If you want to get that, then the link is in the description, right? Now let's see if you want me to cry or you want me to feel happy by seeing your comments, right? Okay, bye bye.